Welcome to second day of this conference.
Table. There's hydrogen and helium and lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for
The periodic table.
There's hydrogen and helium and lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium.
aluminium, silicon, phosphorus, then sulfur, chlorine, and argon,
Potassium.
and calcium so you'll grow strong,
Scandium.
Helium, titanium, vanadium, and chromium, and manganese. This is the periodic table. Look at the stable. Halogens and alkaline react aggressively. Period will see you ever shuffle electrons are added moving to the right. I reach the 26th and cobalt nickel points again. Copper, zinc, gallium, germanium, and arsenic, selenium, and chromium. Tungsten, rubidium, strontium, and yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium, and indium, tincan, antimony, and tellurium, and iodine, and xenon, and cesium. Barium is 56, and this is where the table splits. Well, and the nights have just begun. Lanthanum, cerium, magnesium, neodymium. Neodymium's next to promethium, then 62. Samarium, uranium, gadolinium, ytterbium, strontium, holmium, erbium, helium, terbium, lutetium. Hafnium, tantalum, tungsten, rubidium, osmium, and iridium, platinum, gold, to make you chilly gold. Mercury, to tell you when it's really cold. Thallium, and lead is for your tummy. Polonium, actinium, radon, and cesium, will last a little time. Radium, then actinize as halide. This is the periodic table. Look at the stable. Halogens and alkaline react aggressively. Each period will see new hydrogen electrons to the right. Actinium, thorium, protactinium, uranium, plutonium, plutonium, uranium, curium, beryllium, chlorine, actinium, chromium, molybdenum, nobelium, lawrencium, beryllium, magnesium, radium, mercurium, oxygen, beryllium, potassium, nihonium, flerovium, moscovium, lerorium, tennessine, and organissum, and then we're done. Thank you guys so much for watching. If you like the song, make sure you check it out on iTunes and Bandcamp with the link below.
If you think you enjoy videos like this, make sure you subscribe to our channel. We'll put some of our recent videos over there, so you can check them out.
You can also check out asapscience.com. Dot isn't the best way to try to sum up how electrons come and go. Near the states of a matter field that follows an equation that Dirac wrote. Schrodinger part of the whole equation will just lead in sub C when it expands. Now can I cool up and add it in with the proton and watch them start to dance? Hydrogen and psycho proton, I feel your tug. Central potential dip down pulling on me, but I'm not pulling it deep. No, that would break uncertainty. Say, oh, the electrons go too much. Slow down your pace and put that orbit on me. Come on now, follow my lead. Come on now, follow my lead. Orbitals take the shape they do. The stable states of the quantum ghost. And when a wand approaches you, they can combine and combine. Thus hydrogen as a rule is from the nature as H2. Energy can be ring of a molecule. The atomic bonding. Down into the ground state with the speed, quadruple degeneracy. The second shell can be filled up to date. The higher angular rod spread all the beautiful flowers and middle families that come into play. We'll use the carbon with 6C to say not to Trixie, but we're gonna make something today. With hydrogen and psycho atoms, I feel your tug. Got my electrons fucked up, pulling on me. Come on now, settle around me. I'll hybridize to ST3CO. Carbon, yes, I touch. Spread out 109.47 degrees. Come on now, follow our lead. Come on now, follow our lead. Molecules take the shape they do. Converting states with the quantum ghost. The potential goes as we do. Simplified up a bonding. And as widely as their purview, spread it in the molecule. The condensing ring, they hold it true. The parallaxic quality. Parallaxic quality. Parallaxic quality.
Ma'am, you are muted.
You are not audible. Unmute your call. Sandeep sir, open करा. Sandeep sir. हाँ, next sir केलं. Sandeep sir. एक भी अपने पास बाकी नहीं है. सब देखा हमने इसमें. रिपोर्ट सर से भी लिया. मैम वॉलंटियर चाहिए है सर. किधर भी. Yes, thank you so much. Thank you. Yeah. Good morning, everybody. Good morning, ma'am. I spoke to Savan sir. He will join by 11:30, 11:45. And he said he will not present anything. He will just give an overview of the files. Presentation. You are
Now can you see?
Yes.
Yes, sir, you can go ahead.
No. Anchor, please take a charge.
Yes, ma'am.
Yeah.
So can you stop presenting for a while?
Sir, sharing.
Thank you, sir.
एकच मिनिट हा. रोहिणी मॅडम प्लीज रेकॉर्डिंग चालू करा अगोदर. रोहिणी मॅडम.
Ma'am, it's already started, another software.
आम्हाला दिसत नाही ना इकडे म्हणून. हा, बर. प्लीज टेक अ चार्ज आपला.
A very good morning to one and all. Welcome to the virtual national conference on advances in chemical science and sustainable development. I am Aprajita Kanoja from Institute of Science.
I am Ms. Khan Hiba from BPM BN Bandodkar College of Science.
Welcome you all again for the second day of national conference organized by BPM's BN Bandodkar College of Science. Whether you have just carried or already had a good day with us yesterday, we want to welcome you warmly and hope you grab the knowledge and information the day ahead.
And we are truly blessed to collaborate with Dr. Homi Bhabha State University, the Institute of Science. I would like to thank Dr. Jairam Khobragade sir, the director of Homi Bhabha State University, for giving us an excellent opportunity to collaborate with the college. Thank you so much, sir. Over to you, Kavya.
Hello everyone. Hi, Ms. Kavya Kohli, profusely elated to take an opportunity to introduce our chair, Dr. Anita Goswami ma'am, Associate Professor at VPM's Bandodkar College of Science, also in charge of Biochemistry Department. She has published more than 90 research papers in peer-reviewed journals. She has got second position for paper presentation at international conference, Aurangabad and Pune. One of the paper presented in international conference on biosensing technology has awarded as a star paper at Netherlands. She is also chaired session at international conference and was co-convener and chief guest at state level. She was organizing secretary of state level seminar for women empowerment. It has to glance, she is a body of Samaj Bhushan, Yashwant Chauhan, Samasta Gaurav Puraskar, Shak Bhushan, Paryat Puraskar, and many more. She has got 4 patents and recipient of Best Teacher Award from University of Mumbai.
Along with her, our co-chairman, Dr. Homi Baba Sir, Assistant Professor, Department of Chemistry, the Institute of Science, Dr. Homi Baba State University, Mumbai. Dan his MSc in Chemistry from Amravati University. He received his PhD from SG Amravati University in 2012. His research interests include hardcore organic synthesis. Over to you, ma'am.
Thank you, Kavya. Today's first talk on will be given by Dr. Muralidhar Ingale, who is Director R&D Technology at Advait Pharmachem Private Limited, Barodara. Sir has obtained his PhD from in ICT, Mumbai in 1995, and he has versatile working experience in the field of fine chemicals, agrochemical, then pharmaceutical, and he's associated with this institute from 2013. He has experience in various chemical reactions, expertise in process research, like optimization and validation, business development and quality analysis. He has some success stories are like methoxyamine, then 1,3-CSD developed in 2004 at Deepak Nitrile Limited, Vadodara. And for this success story, he has honored as a special appreciation award with the award from the institute. And sir is also work on the CRMS project for the API development at Calyx Pharmaceutical and Chemical Limited. Then sir has also worked at Tila Industry Limited at Udaipur, and he developed their agro ingredients at tolbutarides and fumindamides, 5-CAPM, NN106, then pithoximide, like this. And he also developed the test facility member as a test facility member at GLP establishment. Sir is also work at Acme Life Sciences, where he has developed the process for preparation of thiamine derivatives, then benfotamine, and commercialized the drug for first time in India. And for this also, he published his patent, which is granted. Then later modified the process with the CUPC and which is highly polluted with respect to the ammonia. And the process is very eco-friendly. Also, the patent is granted on this processing. In recognition with the work by the Read Business Information Relax Group UK and elsewhere publication, he has awarded. He was the recipient of Alpine Innovator of the Year 2017. Sir is also work at FNC, Cheminova Limited, responsible for the development of improved AIs and their raw materials, azoxy, scobin, and cartap hydrochloride. On this, also he worked nicely, and he has shown his excellence in the processing as well as the substitution reaction. Then, sir was also developed, commercialized the valencepacin hydrochloride and phenylamethrin hydrochloride, and for this also he has obtained the patent on specifically the intermediate for which phenylphrenin hydrochloride, where he has developed various intermediate in the form of salts. Then followed by also he mainly got the etopride hydrochloride and pranoclast. In total, granted patents are 4, as published international publication 8, and recognized one of the 100 most impactful health care professional at the global listing by the World Health and Wellness Congress. Sir, along with this, sir is also awarded the excellent work in chemical and pharmaceutical process development from the Director of Entrepreneurship by the Development from the government of Uttar Pradesh. Along with that, sir is also honorary member of Royal International Pharmaceutical Law International Society, as well like member of the Foundation of Health Environmental Research. With this, I welcome you, sir.
Yeah, thank you very much.
I request you please take a charge and let us get the benefit of your knowledge. Thank you so much. so much.
Thank you very much. Can you see the presentation?
Yes, sir.
It is visible to everybody?
No, sir. No.
Not it.
Anita madam, just guide, sir.
Sir, the same way again you have to go.
Yes. I'm trying.
Yeah.
I think it's now visible.
Yeah. Yes, sir.
Okay. So good morning, everybody. Today we are going to discuss some strategic approaches for optimizing performance and streamlining the operation to foster the quality growth for the chemical industry. See, chemical industry is widely recognized as a vital component of human life. So you just name water, food, medicine, plastic, fertilizer, soap, sanitizer, clothes, digital assets, and the list is long and is well regarded. See, nowadays in a chemical industry, there is a stringent requirements from the regulatory bodies like Pollution Control Board, then Food and Drug Administration, and of course our customers demands various new properties or new innovations in our product. So for the chemical industries, it's become necessary to become sustainable throughout the life cycle of the product, and the industry also want to become sustainable for its future. In old days, previously this companies pursuing a sustainable agenda was more focused on the cost reduction. So there was not much focus on environmental impact, achieving the quality compliance by changing the process or by changing the pit stocks or by changing the operations. But nowadays, sustainability of the product has,
just
yes.
you. Please make in slideshow mode. Slideshow.
Yeah, thank you. So sustainability of the product or the process is now become a top priority for the chemical business, and it is almost for all chemical industries. This sustainability not only reduce the cost and reduce the environmental impact and carbon footprint, but it also gives the opportunities to reduce the cost of the product, improves the quality of the product. It also meets the requirement of the customers and consumer. So it is strive to develop the new product, improve the existing process, existing business process, existing product qualities and services that are required to address the need of growing population. So what is the sustainability in the chemical industry? Sustainability is like to be first in the market, and to meet the customer's requirements. Your product should qualify all the requirements. Also, the product should be made by the cost-effective process. So the sustainability gives the growth, it increases the profitability. Is through the sustainability you can manage the risk. It builds integral assets and for the positive future of the industry. So to achieve the sustainability of the product, there are various parameters which need to be addressed, or various aspects which need to be addressed. So this slide shows the various aspects to make the process or product sustainable. So first one is the circular economy. Another is innovation, change thinking. See, then digitalization, DOE, that is design of excellence, and QBD, quality by designs, Six Sigma, and PAT, that is the process analytical tools. So these are the various aspects to address the sustainability of the process. The circular economy is morely concerned with the green chemistry, green processes. So that processes reduce the waste, minimum waste. So circular economy mainly addresses to reduce the waste at the source, recover byproducts from the waste, recycle them and reuse them. So this is the whole concept of circular economy. Innovation, that is a change in your existing chemical process and technology. So this requires investment in R&D. Change thinking. Sometimes other factors, external factors like regulatory bodies, our customers, they demand something different which we are not doing presently. So that needs us to change our thinking. Digitalization, that is the smart business processes, use of AI is artificial intelligence, sensors, robots, a drone, that is for the risk management. See, the use of AI, nowadays we are facing this COVID consequences, and when it was started, the scientists have the biggest problem how to extract the literature from thousands of published paper. So this technique was very useful to extract the required abstract of the literature from millions of research paper which were published. So this is how the AI is useful in chemical industry. Robots and drone, they can use for the risk management. For example, the hazardous material handling like cyanides. In the batch process, in advanced countries, these robots are being used to handle the cyanides. For example, charging of cyanides and handling of the cyanide streams. Drone, they are nowadays used to manage the fire in case in chemical industry. If the firefighter cannot reach to that place, then drone are the best devices to manage the fire. So apart from this, today, because of the time constraint, we are going to discuss only first two, that is the circular economy and innovation in the chemical process technology. I'm going at the right speed, or you need to be, everybody is able to hear? Hello?
Yes, sir. Yes, sir. Okay, sir. Yes.
Okay.
Yes.
So circular economy, that is reduce, recover, recycle and reuse. The concept of circular economy is already fast gaining a traction amongst the business leaders and the policymakers in Europe, China and other developed economics. But its potential for the developing countries like us has so far not been much explored. In India, India is one of the developing countries is set to unlock the climate resilient growth, and the national policymakers are investing in the circular economy. The economic model based on what is circular economy is that the economical model based on reducing, recovering, recycling and reusing the raw materials, byproducts or waste stream coming out of the production process. It is estimated that this could open up the opportunity to the value of $218 billion per year by 2030 in India. So this is the information collected from the report produced by Ellen MacArthur. So taking this chemical industry into circular economy, so why we need the circular economy? It is for the profit, growth, for the welfare of the people, shareholders and the planets. So it gives a complete sustainability of the products when you have everything, when you put everything in the circular economy. The circular economy moves away from the traditional take, make, dispose economic model to that is the regenerative by design. The goal is to retain as much value as possible from the resources, byproducts, process parts or materials to create the system that allows a long life. The optimal reuse, refurbishment, remanufacturing that gives economical and environmental benefits. So this is the difference between the linear economy and the circular economy. Earlier there was a linear economy, just you make, take and dispose. But the circular economy have a different concept that it reduces first, then recycle, then recover, and then reuse again in the same process. For the circular economy, the one important factor to be considered is the use of renewable feedstocks. So using the renewable feedstock that reduces a dependence on the oil industry. Renewable resources are theoretically inexhaustible, and the range of material being manufactured from such a sources continues to go. So there are some examples like surfactants are made which are readily biodegradable. In some cases are manufactured from the renewable plant derivative resources such as carbohydrate, for example, sucrose, glucose, and plant oils. Polyols from soya, which are used to make the polyurethane. Ethane from the bioethanol, which is used to make bio-based polyethylene. Propane is being produced by a variety of ways from the material produced in turn from biodegradable resources. The propane is used to manufacture bio-based polypropylene. 1,4-dimethyl benzene is paraxylene. It is from bio-based ethane can be used to make the polyester. In 2016, the Crasto, the company in Europe, replaces 20% of the crude oil that is usually required in their polyurethane manufacturing process. It was replaced with CO2, and that CO2 was generated in their another plant production process. So the production capacity in this company currently amounts to 5,000 tons of polyol per year. So this much amount of CO2 they have utilized to make the polyurethane. Another example, renewable feedstock is the hydroxymethyl furfural, that is the HMF. It is prepared by the bioforming reaction. So the hydroxyfurfural, if we oxidize, then we get a dicarboxylic acid. The reaction is given here. This is the furfural and it is oxidized to dicarboxylic acid. So this dicarboxylic acid can be replaced with terephthalic acid in the manufacture of PET, that is polyethylene, polyethylene terephthalate. So just simply replace the terephthalic acid with furan 2,5-dicarboxylic acid, and we get the same quality, same type of polyethylene polymer, same type of polymer like polyethylene terephthalate. Carbon fiber reinforced composition can replace the steel and aluminum in various vehicle components, and they reduce the weight of these components by up to 50%. So this results in reduces fuel consumption and also a CO2 emission. The advantage over the lifetime of the vehicle outweighed both the disadvantages from the higher energy conversion in the production of composite material and fact that these cannot be optimally recycled yet. The overall balance of this design to performance is therefore positive. Recently, this new Boeing 878 uses a carbon plastic composite which reduces the weight and it saves the fuel and in turn the energy. Another aspect of circular economy is to replace. So without chemistry, there is no circular economy. One of the key principles of green chemistry is that the process should be designed so that the maximum amount of raw material ends up in the product and the minimum waste is produced, because we don't have any ideal process which doesn't generate any waste. So what we can expect, at least the waste produced should be minimum. So the reaction which have high percentage of yield but also make a lot of waste product, and this kind of reaction has a low atom economy. So both the yield and atom economy have to be taken in account when designing the green chemical process. So this is primarily the main responsibility of the organic chemist who design the process, who design the route mapping of the reaction. So he should consider this thing, the atom economically should be very efficient. So atom economy in terms of percentage is relative molar mass of the desired products divided by the total mass of total products into 100. See, I have given one example how the process is to be decided whether it is efficient or inefficient. See, this simple reaction It is the calcium carbonate. When it's heated, it gives calcium oxide plus CO2. The calcium carbonate molecular weight is 100, calcium oxide is 56, and CO2 is the byproduct, that is the gaseous emission from these reactions. So if you see from the original atoms, one carbon atom and two oxygen atoms are wasted, and they are not in the final product. They are not in the final useful product. It's like a waste gases. So the green chemist define the atom economy as the percentage of atom economy is equal to upon total mass of the product into 100. So in this case, it's 56 into 100 divided by 100. It gives only the 56% atom economy. So remaining 44% is going into the atmosphere and it's the waste. So atom economy is only 30%. In another example, atom economy is 30% the manufacture of phenol by the old process. So old process was the benzene sulfonation, and then its fusion with sodium hydroxide gives phenol. The byproduct was sodium sulfite and water. And, the new technology where the phenol is manufactured from benzene and propene, and this process is more efficient in terms of atom economy. Here this process produces acetone as a byproduct, and that byproduct is a very useful chemical. We know all acetone is used in very large quantities. So around 83% of the acetone consumption is satisfied by the phenol manufacturing process. So this is an efficient process compared to the earlier one decomposition process what we have seen. Then some reactions have 100% atom economy, but they have poor yield. So it is necessary to consider both measures of efficiency. So it is not only the yield, it's also the waste products produced in the reaction. So we have seen in the last two slides about the waste. Now see the yield. See yield. Atom economy is determined at the planning stage by calculation, while yield only be realized if we do some experiments and find out, okay, this is the output for this reaction. So these are the two differences between the atom economy and yield. So yield only realize when we carry out the reaction, when we do the experiments. So some types of reactions have inherently better atom economics. In addition, like condensation reaction, addition reaction, rearrangement reaction will generally have the higher atom economy than the elimination and substitution reactions. So we'll see the example. This is the ethene molecule. If we add chlorine to this ethene, we get the important compound, that is dichloroethene. And here in this reaction, there is no waste byproduct. So these reactions have 100% atom economy. But when this product is hydrolyzed with water, we give this dihydroxyethene plus 2 moles of HCl. So in the first addition reaction, and the second one is the substitution reaction. So next is to reduce and design at source. So we need to reduce the feedstocks, enhance the availability and quality of the existing resources, reduce the emission, reduce the energy and water, integrated use of water in the process, new materials, new raw materials which are economical and easily available, less hazardous. Another is to reduce the amount of any hazardous substances, pollutants, contaminants entering in a waste stream, otherwise released into the environment prior to the recycling, treatment or disposal. Reduce the hazards to the human health and environment associated with the release of such substances, pollutant and contaminant. The term source reduction includes modification, source reduction. Reduce at the source means when we design the batch or when we design the process, at the source, at the beginning, we should reduce it. So how this can be done? There are various ways like modification of equipment or technology. So if one process producing more waste, if it's the batch process, then we need to see whether the continuous process or another options like recently flow chemistry is another thing where we have a better reaction conditions and better outputs in terms of yield and uh, atom atom economy. So these are the various stages where we can reduce the waste, like vapor-based reaction, use of catalyst, uh, operate the reaction under pressure or room temperature, modification of process or procedure. You change the sequence of reactants, addition sequence or their reacting sequences, modification or reformulation or redesigning of the product, substitution of raw materials, improvement in housekeeping, maintenance, training, and inventory control is also part of the uh, circular economy. In redesigning concept, there is one more example here I want to show that paracetamol intermediate, this 4-aminophenol, that is the important intermediate to manufacture paracetamol. In a traditional way, now the industry is making this paracetamol by starting with 4-chloronitrobenzene. It is hydrolyzed to give 4-hydroxynitrobenzene, and hydrogenation gives 4-aminophenol. So, and finally you get a paracetamol. But there is one more reaction where we start with nitrobenzene and hydrogenation in presence of sulfuric acid directly gives paracetamol intermediate, that is 4-aminophenol. So there are many more examples where the traditional routes or the old unsustainable route can be changed the promising one. Second is the use of 2-methyl THF in a Grignard reaction instead of THF, that is tetrahydrofuran. Because tetrahydrofuran is soluble in water and its recovery almost impossible from the downstream processing of the Grignard reaction. Whereas 2-methyl THF, which is negligibly insoluble in water, and almost 96-97% 2-methyl THF can be recycled and reused in the process. So this gives the more economical advantage and also the reduction in the waste compared to the THF process. The use of trifosgene instead of phosgene gases, because phosgene gas is prepared by high temperature reaction of CO and chlorine gas. So everybody cannot make phosgene gas in their premises. So the best option is to use a trifosgene, which is very safe for handling and comparatively non-hazardous compared to the phosgene gas. So many reactions like preparation of isocyanates, amide dehydrations, and then oxychlorination, this can be done using a trifosgene and no need of phosgene gas. Use of the catalyst, that is chloro replacement with ammonia, generally take place a longer time and high temperature, high pressure. So the metal catalyst like copper or maybe sodium cyanide can be the best catalyst to replace a chloro displacement. Chlorination of alcohol using POCl3 and tetrabutyl ammonium tetrabenzyl ammonium butyl chloride catalyst make the reaction happens at 25 degree. So there are various promising reactions can be done at using the catalyst. Next slide, we will discuss this more. Just a minute. Hello, मेरे को टाइम है, आप उनको बोलो कर लो, मैं बात नहीं. Sorry. So one case story I want to highlight here, that is recover and reuse concept of circular economy in a very big molecule, copper phthalocyanine. This dye is produced in a very big way in India. About 6,000 metric tons per month of this product is produced by conventional process where phthalic anhydride, urea, copper, chloride, catalyst and solvents are reacted. One of the drawback of this process is about 1 to 1.5 tons of ammonium carbonate solution is produced in the process, and disposal of solution is the biggest problem for the manufacturers. So the process was modified that uh, ammonium carbonate solution, whatever the produced by the reactions, were completely recycled back into the reaction by making an intermediate which was getting formed during the reaction. So here, when about 95% solution which obtained as a waste solution from the process is completely recycled, and process become more sustainable and economical with respect to environment and cost. So these are some highlight that the conventional process generated 409 kg of ammonia gas along with CO2, where the modified process generates only 266 kg of ammonia, and that ammonia is totally recycled in the process. So these are some highlights of the process, and this gives a complete economic financial benefit of 20 lakhs per month for the 100 metric ton capacity plant. This process was also awarded as an innovation award by elsewhere Relax Group UK. Another recycle and reuse comes to the plastic, paper, and glass recycling. In our country boasts one of the highest plastic recycling rates in the world. It recycles and reuses over 90% of all PET that is manufactured in the country. Chemical manufacturing and plastics in particular have emerged as the key target for the circular economy movement, and for the good reason, because we must recycle them. 13 US dollar billion is the damage to the marine ecosystem caused by the plastic waste each year in the United States. That 95% approximately the plastic packaging material, or 80 to 120 billion in economic value, that is lost annually because of the short first use. And according to the report of 2016, 70% sorry 70% of plastic packaging is not recovered, and according to this report, 40% end up with landfilling, and it goes to the collection system. Innovation in a chemical process and technology. So chemistry is the science behind in sustainability. Innovation in chemical process and technology. So here, what we are going to see, what are the new technologies, new methodologies are adopted to overcome the current issues or current problem, or to meet the today's requirement. The innovative product of the chemistry lead to the cutting edge advancement. Applied technology in medical devices, advances in the drug delivery systems, aerospace, computing field, cars, fuels, and many more. So that's why the chemistry enables technical and advancement, which drives innovation, which creates job, enhance the safety in our everyday lives. In 2080s, the US chemical companies invested nearly 10 billion in the research and development, and investing more to innovate than the electronic, automobile, and healthcare industries. The business of the chemistry excel at continuously bringing the new, imaginative, innovative ideas to the market, and tomorrow will be no different. Here are few examples. Like chemistry in nanotechnology is the breakthrough. Nanotechnology is the science of extremely small structure and is leading to the advanced material devices application in energy, medicine, and electronics that improves our life, healthcare, safety, and the environment in a groundbreaking ways. The nanotechnology has many drivers application, and some of which includes delivering drugs to the specific cells. So this is in a medicinal field. So repairing damage to the human tissues, for example, cancer treatment. Then improving the efficiency of solar energy production, enabling the lighter and high performance plastic for the aerospace, construction, and vehicles. Chemistry in computing field. So widespread use of touch screens enabled by the physics, enabled by the plastics, adhesives, and other products of chemistry are employed on cell phone, PDAs, computer screen, and more. Thinner screens soon will be applied to the windows, consumer products, and plastic displays, public displays to enable increased interactivity and commerce. In transportation, auto and aerospace designers are turning to strong, durable plastic that weigh much less than the traditional material and help to save the energy. In agrochemical area, we have the nanopesticides. They have the potential to stop the pest without hurting the bees. So this protect the bees from the pesticides. The nanoformulated pesticides can deliver the active ingredients where they are needed without polluting the environment, or like neonicotinoids, they have been accused to do so indiscriminately to kill the essential wildlife. So more efficient agrochemicals are urgently needed to support the global population that will reach to 10 million by 2015. So far, only few studies have been shown that nano agrochemicals are actually more efficient than their traditional counterparts, and none of them have been tested in the field yet. So this is the very gray area for the agrochemical industry to develop the nanopesticides, which are useful uh, to save the environment or to save the wildlife, and they only act to the required act at the required point. Another innovation lies here the enantioselective selective organocatalyst. In chemistry, there are many reactions where we need to separate the isomers and we do need to resolve the isomers. So the traditional process of resolving the isomer generate a lot of waste. Then the recovery of the resolving reagent is also required. There are losses, so the economic of the process is not fitting in a criteria. So the enantioselective selective catalyst gives you the desired product in a very high enantiomer purity. So the idea of replacing expensive or unsustainable metal catalyst with a small organic molecule is inciting for the synthetic chemists. The organometal catalysts are often more robust than their metal cousins, and some type like sugars and amino acids are easily available as a single enantiomers. There are now hundreds of enantioselective organic catalytic reactions. For example, fluorine catalyzes aldol condensation to epoxidation, which uses the modified fructose catalyst. So fructose is a natural substance. So carbon-carbon coupling is one of the big is a difficult reaction in the life of organic synthetic chemists, because these reactions are not easily going, and they requires a very precious metal catalyst to form the carbon-carbon bonding. So the metal catalysts which always have the upper hand, but recently, because of the innovation taking place in the field of synthesis, this scenario is changing, and what researchers have found that the recent phosphorus catalyzed cross-coupling reaction also have shown the promising result. So here what we can say, the phosphorus beats palladium in connecting nitrogen rings. So phosphorus reagent can couple the rings, nitrogen ring, and also carbon rings also, not only the nitrogen, but the phosphorus reagent can couple the ring that metal catalyzed coupling struggle. So for example, joining the pyridine rings in a antihistamine drug, loratadine. The challenge remains here, achieving every cross coupling you want, because the phosphine is going to be at the 4th position of pyridine. So it will be great if somebody can find out the phosphorus based catalyst or ligand which have the ability to form the to couple at the 3 position of the pyridine ring. So this is the gray area for the phosphorus ligand catalyst. Another area is flow chemistry, where we can do the innovations in our chemical process. So flow synthesis is already proven to be a cheaper and high-yielding, less waste generating, and sometimes the safer process compared to the batch production. So both in laboratory as well as on the industrial case. It also lead itself to automation, allowing the chemist to run thousands of reactions in a very limited time, where it is not possible to do a batch reaction, because batch reaction you need, if you want to carry out more reaction, you need to have more batch reaction setups. So combining continuous flow chemistry and polymer synthesis can produce the compound that would be hard to make in a flask. The flow synthesis requires specialized equipment, although there are some unique low-cost solutions. However, there is no need to work on the downstream processing to make the complete flow or the continuous process, because flow chemistry now up to till till date, it's used to carry out the chemical reaction, but the downstream processing like separation, then distillation, and the filtration, or maybe isolation of product. So these are not done by the flow process. So there is a need for the organic chemist or the chemical industry to work further in this area to make a complete flow process right from the beginning, like reaction plus downstream processing. Flow chemistry consists of a reactor. Reactor can be coil type, microchip type, column type, or microsphere type. So this is the reactor where the reactants are pumped and mixed together and passes through this reactor, which is temperature controlled as per the requirement. There is a back pressure regulator which controls the pressure of the reactor, and then very sophisticated equipments, there is an online analyzer like IR probe or NMR probe, and then after analysis there is a quenching line, whether to dilute the solution or to mix with some solvent, and there is a phase separator, and finally the purification. So but this downstream but the downstream processings are not much developed in the area of the flow chemistry. So this window, this is the process window where the flow chemistry can be applied. If we have high temperature reactions, very high pressure, we have explosive region, then if we want to carry out the reaction with high concentration and maybe solvent free or with the lesser solvent, then all these problems can be taken care by the flow chemistry or the flow reaction. So what is flow chemistry? It's sometimes referred as a plug flow reactor, or the continuous flow chemistry. The process of performing chemical reaction in a tube or in a pipe. The reactive components are pumped as shown in that previous figure. They are pumped together at the mix and mixing at the junction, and then flowed into the reactor, which is temperature controlled. The reactor may contain pipe or a tube or maybe drafted structures. So this provides a major disadvantage, such that the faster reaction, major advantage like a reaction are very faster, cleaner byproducts, safer reactions, and very easy to, these reactions are very easy to scale up. What are the benefits of the flow chemistry? As we have seen, their reactions are very fast. We can also pressurize the reaction. Pressure in the flow reactor, there is a the reaction can be allowed to heat up to 150 and even more, up to 200 degree also temperature. These reactions can be operated under pressure or maybe at atmospheric pressure also. So if we carry out the reaction at such a high temperature, then the reaction rates are very higher, almost 1,000 times more compared to the normal reaction, and this is called the superheating conditions. These are some examples of the flow chemistry versus batch process. So if this rufinamide intermediate, if we do in a batch process, then the 28 hours, there are the various conditions. If we compare this reaction, for example, 135 degree, 0.5 molar NMP solution, so 1 hour gives only 30% yield. That is the flow process at 135 and 1 hour time, it gives 43% yield. So always there is an advantage of this flow chemistry with respect to yield, with respect to waste generation. So the advantage of using flow reactor technology in the most cases is directly related to the size of the reactor, which can be which can be achieved a series of properties unreachable in the batch type reactor or the bench scale reactions. Rapid and efficient mixings of the reactant because of the small volumes and large available area. The mixing is very proper. Efficient heat transfer, very limited amount of reactant is undergoing in the reaction, so a large amount of surface area is available to manage the heat, so efficient heat transfer is there. Low operating volumes, so only small volumes are the reactor volumes are not very big, they are very small volume, but the continuous, because of the continuous flow we can operate the very large volumes. High temperature and pressure conditions can be achieved with the help of back pressure regulators. High concentration or no solvent, even the neat reactions can be carried out in the flow reactor. Inherently, it is safer compared to the batch because batch we need to handle a total volume at a time, where in the flow reactor only small amount of reactants are ingoing and a small amount of reactants are coming out of the reactor. So handling of the volume is also advantageous. It is inherently greener process, and this can be scaled up by just putting a parallel processing unit and intensifying the process. So easy to scale up. Products are very cleaner because the reactions giving you the excellent results, like in terms of yield and waste. So the products are cleaner, no need, purification treatments are less required. The flow reactor enables the excellent reaction selectivity, rapid diffusion and mixing, avoids the issues found in the batch reactor. Because batch reactor, all the raw materials are reacting at a time in a single reactor. The high surface area to volume ratio, that is 1000 into, is greater than the batch reactor, enable the most instantaneous heating and cooling. Therefore, the ultimate temperature control is possible. Reactions are safer. Flow chemistry allows only small amount of hazardous intermediate to be formed at any instant, and the high surface area also allows the excellent control of the exotherm. So all the hazardous reaction which generate or which are exothermic reaction, highly exothermic reaction, are best controlled or done by using the flow reactors. As earlier also I have mentioned, it's easy to scale up. Scale up issues are minimized due to maintaining excellent mixing and heat transfer. Higher flow rates and considerably large reactors can be used to easily produce kilogram quantities. It's just multiplying the units of the flow reactors that can be scaled up from small quantity to the higher quantity. The reaction conditions not possible using traditional batch chemistry reaction. The flow chemistry facilitates the reaction condition not possible in the batch reactor, such as 5-second reaction at 250 degree and a multi-step procedure such as rapid low temperature deprotonation followed by instantaneously by the addition of an electrophile. A high temperature are made easy. This section provides the information about the application of flow chemistry. Another innovation is mechanochemistry. So mechanochemistry is the chemistry where the reactions are made possible by the action of mechanical forces. So the mechanical forces sometimes makes the chemical reactions possible. For the best example, which are where this mechanochemistry is applied in the manufacturing of this aspirin molecule, where you need to do the carbonation of phenol. So the phenol and the CO2 gas, they are put together in the reactor, and the mechanical forces, for example, the ball mill, they produce salicylic acid, 2-hydroxysalicylic ortho and para isomers. So CO2 and phenols are reacted in the ball mill, where the mechanical forces do the chemical reaction, that is the carbonylation take place during this process. So this process works on the molecular scale and even in the industrial scale also. There has been a scale up of mechanochemical processes. For example, the reactive extrusion is a polymer manufacturing technique this combining synthesis and shaping into single solvent-free process. So it is essentially a solid-state flow chemistry. So this is nothing but the branch of flow chemistry, but it is a solid state. Only the solid compounds are reacted. Solid or gas solid. Gas and solid compounds are reacted. Gas and liquid compounds are reacted. So it could be the way to scale up electrochemical processes when they have already demonstrated that they can make MOF by screw extrusion process. So MOF, that is metal organic frameworks, are manufactured by the screw extrusion process. What are MOF? They are the metal organic frameworks, and they are capable to do the gas separation, gas absorption, catalysis, carbon capture. This MOF are already made into the commercial product like gas storage. IUPAC judges the witness that the sponge-like material, MOF, has the ability to capture water from air. Even the humidity is as low as 20%. So the device made from MOF can capture and release several liters of water per day using only sunlight with no additional energy is required. So these are the very innovative materials, and they are useful for the humanity. Another area is in the case of enzyme directed reaction. They are the good chemical catalyst. As recognized that in 2018 Chemistry Nobel Prize directed evolution produces enzymes that perform reactions new to nature. No natural enzymes make carbon-silicon bond or highly stained carbocycles. This molecule can also be made by traditional way of synthesis, but might involve a costly and a dangerous reagent. The streamlined enzymatic processes of sitagliptin eliminates the high pressure hydrogenation and all metal like rhodium, iron, and the wasteful chiral purification step. The benefit of the new process includes 50%, 56% improvement in the productivity with the existing equipment and 10 to 13% overall increase in the yield and 19% reduction in the overall waste process by use of enzyme instead of rhodium and iron catalysis in hydrogenation. So thank you very much. I hope I tried to cover most of the things. Hello.
Thank you, sir.
Yes, thank you, sir.
Any questions for our audience?
Hello.
Yes.
Sir, when the process is moving from R&D to plant scale, means scale up the reaction,
okay,
then is there any impact on the yield and atom economy of that reaction?
No. Atom economy remains same in the laboratory as well as in the pilot scale. See, whatever the losses we get only because of some of the scale-up issues. Otherwise, these are the inherent factor. If they are, if the atom economy is for example in the laboratory, if it is 75%, then it will remain same if we operate under the same conditions.
And the yield, sir, yield.
Yield depends on the yield depends on the operational conditions also. Because so there are some scale-up issues like scale-up issues with respect to mass transfer and then heating and cooling area available in the scale-up reactor. But if you match the conditions of the laboratory, then there won't be any problem in the yield. Because I personally experience many companies, they don't have the pilot scale to scale up the process. So people are taking even a 200 gram batch lab scale process to 500 kg at a plant scale, and they are going very successful without any deviation.
Okay, sir. Thank you.
Hello, sir. I'm Dr. Vikas Bangde.
Yes.
Sir, actually,
yes, Vikas.
I have the question that actually, sir,
yeah.
Thank you very much for the introduction about the flow chemistry. Sir, actually, microchemistry is little different than the flow chemistry, but founder of the C. Oliver Cafe, founder of microchemistry, who is a C. Oliver Cafe. He is in the University of Greenwich. So, sir, he has founded, but he moved to the flow chemistry. So, do you have idea why he did it and what are the differences between that?
Microwave chemistry is growing, is a very infant branch of the synthesis. It is not fully developed. You can do a small scale reaction in the laboratory with the microwave one, but the scale up there is no scale up reactors are available for the microwave.
Yeah.
And microwave is just performing the heating operations and some radiations generated by the heating pattern. But it has a very limited resources available for the scale up of reactions.
Okay. Sir, do you have setup of flow chemistry?
Flow chemistry, yes, we have set up.
Yeah, okay. Thank you very much, sir. If I will not, I will just request you. I have to I have to learn about the flow chemistry. I'm really interested.
Okay, anytime you can discuss and call me.
Yeah. Thank you very much, sir. Thank you.
Okay.
Good morning, sir. This is Mohan Sagre, sir. Actually,
yes,
sir, my question is, there is any relation between atom economy and yield of the product? And second, my question is, can you please again explain about the disadvantages of flow chemistry, sir? Please.
Okay. See, first the question, atom economy and yield. These are the two different things. Atom economy is you can calculate it by balancing the equation. And it's simply the ratio of amount of product divided by the desired product into 100. So it's a theoretical prediction of the reaction that is called as the atom economy, and it speaks for all reactions.
Okay.
But yield is a different part. Yield is the reaction between two components and getting the desired product in terms of weight. Okay. So atom economy we calculated on the basis of the molecular weights.
Okay.
And yield we calculated on the weight of actual product obtained after performing the reaction.
Right, sir.
Okay. I think you got it clear.
Yes, sir. Yes.
Okay.
Hello.
So the second question was your disadvantage of the flow chemistry.
Yes, sir.
So flow chemistry doesn't have any disadvantage at all. Only the thing is that there is a need to explore this flow chemistry further to the reaction. But after the reaction, see, reaction can be happened in the flow reactor very well compared to batch reactor.
Okay.
But the downstream processing, because the flow is coming from the reactor and you have large volume of the product, maybe in the solvent, maybe in the water, and we need to separate that product by the way of filtration, by the way of distillation, maybe separation. So all this downstream processing, there is no techniques available in the continuous way or in the flow way to perform and to isolate the product.
Right, sir. Actually, sir, I'm using VaporTech, and in that case, means whatever raw material I'm use, it should be soluble in the solvent. So if I use suspension reaction mass, then we can't use VaporTech. So this is the limitation of VaporTech. So is there any limitation in such limitations in flow chemistry?
Yes, flow chemistry, say a slurry up to 60%, 40 to 60% solid can be handled in the flow reactor.
Okay.
Because your VaporTech is a very small reactor which is used for the research purpose. It's
Right,
not a industrial reactor. Okay. So your capillary, this VaporTech capillary where the reactants go are very thin capillary. So you cannot handle. But the industrial scale reactor, even a small reactor in the lab, can handle the slurry having the concentration around 40 to 50%, maybe 60% also.
Yes, sir. Okay. Thank you, sir. And sir, if I have any doubt, if I call you, for the same. Can you please help me out?
Yes. No, you can call anytime.
Thank you, sir. Thank you so much. Thank you.
Hello.
Yes.
This is Bhabha from Dabade, sir. Good morning.
Yes, sir.
Just
morning.
want to ask, suppose you're having some API, active pharmaceutical ingredient, that is having some photosensitive or light sensitive or oxygen sensitive. So it is very difficult to build this formulation or analyze. So it is possible to mask this activity like photosensitivity, light sensitivity, or the oxygen sensitivity to complete or to create a good formulation.
Can you repeat because I am not getting your question?
Suppose any API, active pharmaceutical ingredient, having some photosensitive, that is light sensitive or oxygen.
Photostability issues are there.
Yes.
Okay.
So suppose this API goes in formulation development, that is dosage forming capsule, tablet, or in injection. So photostability issue is creating so much problem in formulation development. So is there any possibility to mask this activity in API development stage only?
Probably you can, if your process accepts, then you can use some photo. What we can say this. There are abstractor, photon abstractor, light abstractors, small quantities, or you can mask your equipment so that the light should not go there. The formulation, what formulation you are doing? Tablets or injections?
No, any formulation. Suppose if I want to ask, suppose in API development stage only, in research development of active.
So if it's the API case, then probably we cannot add any foreign material inside into the formulation batch, because it will change the composition. So what you do only to avoid the physical presence of light, maybe that operation to be done in a very close room, light sensitive room.
No, that is taking care of.
Like what we are doing for the old days, this photo developing room, that kind of room you can use for the formulation.
Okay, thank you.
I hope all the queries are solved.
I think we will stop now. If questions are there, please put it into the chat box. We will forward by email to our guest, and he will definitely give the answer of all questions. So with this, I thank you so much to Ingale sir. Nicely given the difference between the circular economy and linear economy, along with the green principle of green chemistry, which is renewable, reduce, and redesign at source level as well as the processing level. And one can also differentiate between the product and reactant. And if inefficient processes are there, one can replace there by giving the alternative processes. So as you know, he has given very nice example of the plastic recycling, which is the key component for the circular economy of all countries, including the European as well Asian countries. So sir, explain along with this the flow sheet diagram of processing as well flow chemistry, enzyme mediated reactions, etc. So with this, I thank you so much, sir, to hear and given us the knowledge and share your all ideas to us. Thank you so much. Thanks once again.
Thank you very much. Thank you.
Thank you so much, ma'am, for introducing our speaker, Dr. Muralidhar Ingale, sir. Thank you so much, sir, for your thought-provoking strategic approach would give remarking growth for chemical industry. Thank you, sir.
Thank you very much. Thank you very much.
Over to you, Ritanki.
Thank you, Kavya. Myself, Ritanki Tripathi from Institute of Science, Mumbai. Our next talk is on the topic Topography of Molecular Electrostatic Potential by Professor R.N. Shirsat. And for this, I would like to put the spotlight on our next chair, Dr. Vandana Kamble, and co-chair, Dr. Vikas Banke. Our chair, Dr. Vandana Kamble, has been serving as the Associate Professor in Department of Chemistry, Institute of Science, Mumbai since 2011. Prior to that, she was an Assistant Professor in MU Mahavidyalaya, Udgir, Maharashtra. She has extensive experience in multi-step synthesis of organic compounds. Her research papers are published in reputed international journals of high repute, along with participation and presentation of research papers in conferences, symposia. Her current research is on deoxymation of aldoxime and ketoxime by pyridinium fluorochromate and synthesis of biphenyl isoxazoline derivatives and its biological activity. Our co-chair, Dr. Vikas Bangre, has been serving as the Associate Professor in the Department of Chemistry, the Institute of Science, Mumbai, since 2015. He has done his PhD in CSIR Lab, Medicinal Chemistry and Pharmacology Division, IICP, Hyderabad. Some of his papers published are DAPCO catalyzed highly regioselective synthesis of fused imidazo heterocycles in aqueous medium, EMF mediated Henry reaction of cisplatin, and efficient synthesis of 3-hydroxy 2-octane. Her area of interest consists of study of heterocyclic compounds as anti-cancer activity, its synthesis as per green technique, and chemical synthesis under microwave irradiation. Dr. Vandana ma'am and Dr. Vikas sir to kindly take over the session.
Hello. Thank you. Thank you, Vitanki, for kind introduction. A very good morning to one and all. I deem it a great honor and privilege to be a chairperson for the second talk of today's session of National Conference on Advances in Chemical Sciences and Sustainable Development 2021, which is organized by Department of Chemistry, BPM's BN Bandodkar College of Science, Thane, with collaboration Dr. Department of Chemistry, the Institute of Science, Mumbai, Dr. Homi Bhabha State University, Mumbai. It's my pleasure to introduce Professor Rajendra Shirsat, speaker of this session. He is currently a professor of physical chemistry, School of Chemical Science at Goa University, Goa. He has vast teaching experience in subject quantum chemistry, group theory, spectroscopy, computer application in chemistry, classical, statistical, and reversible thermodynamics at postgraduate level. He has been delivered a large number of lectures as a resource person in refresher courses in the universities in Gujarat, Maharashtra, Goa, Karnataka, and the Kerala states. His research interests are in the area of theoretical and computational chemistry, focusing on the application of molecular electrostatic potential. Dr. Rajendra Shirsat received his PhD in chemistry from Department of Chemistry in 1994 and a MSc in physical chemistry from Pune University in 1989. He has also qualified CSIR NET in 1994 and he did BSc in chemistry from Bandodkar College, Nashik, University of Pune, India. He has visited France, USA, and Germany for his research work and presented presentation for her research work. Professor Rajendra Shirsat has more than 25 research papers published in international reputed journals. He has co-authored a book, Electrostatics of Atoms and Molecules, with Professor Grade in 2000. Professor Rajendra Shirsat has given more than 50 invited talks, including conference presentation. Today, he is going to deliver invited talk on topic topography of molecular statistical potential. I would like to invite Professor Rajendra Shirsat to enlighten the audience, and I welcome you, sir. Now the session, we just deliver your talk, please.
Okay. Can you hear me, madam?
Yes, sir.
Yes. Okay. I thank madam and the organizers for inviting me for this conference during the online seminar. I also thank Rohini for sending me a message regarding this. Okay, so I'll just present my slides and please let me know whether it's working, just to start with. Can you see my slide? Are you able to see my slide?
Yes, yes, yes.
Yes, yes, yes.
Yes? Okay. And madam,
Yeah.
You are not recording this? I don't see any recording of even the earlier talk also.
It's being recorded, sir, on YouTube streaming.
Okay, no. Okay. So thank you very much. And let me start. I request others to put their mic off. Vandana madam, you can put your mic off.
Yes.
And please inform others to put their mic off so that audibility is clear. Okay, so I have divided my talk into two parts. One is a little bit introductory and other is at a research level. So basically I'll be talking on topography of a molecular electrostatic potential. Okay. Then to start with, there is always a question to the students whether they like experiments or they like theory, or whether they like lectures or the labs. And the obvious answer to this is this. General observations for this are this. Students like experiments. There are various reasons. Okay, they don't like theory, but they like experiments. One of the reasons is nobody fails in the experiment. Everybody passes, they get good marks in the experiment. One more observation is that they have a lot of freedom in the experiment. They have translational degree of freedom, rotational degree of freedom, and vibrational degree of freedom, all degrees of freedom in the experiment, which is not there in the lectures. Okay. Even teachers also like experiment because they also have a lot of freedom in the experiment. They don't have to actually prepare for the experiment. They can just go, sit there, and do various things. And also it counts for maximum workload of the teachers. Okay. Also, one observation is that the examinations like NET, SET, GATE, even now PET, they only ask questions on theory, not on the experiments. That is also because of various limitations. So these are the observations. So people like experiments, people don't like theory. I saw earlier talk also, mostly people like to see the processes and things like that, how they work. The theory behind that, people may not like that much. Okay, this is the observation. Then there are basically two equations in chemistry. There are basically two equations in chemistry. One is this equation called as Schrodinger time independent eigenvalue equation, and another is ideal gas equations. So if you see this, these two equations are very, very familiar. This equation I will say that this is like based on mostly practicals. Okay, and this is basically like a theory, based on theory. So I'll just explain a little bit of this and then go to my talk, which I actually wanted to take. So you can stop me at any point, there is no problem. I have given a slide numbers, so you can also ask me to go to that slide so that I can tell. So another observation. The experiments normally are carried out at a macroscopic level. Molar level or macroscopic level. There are also some organic chemistry experiments,
than at micro scale, which is a misleading thing, but mostly the experiments are macroscopic level. And at the macroscopic level, we have this equation, which is well studied in thermodynamics right from the 11th standard. T is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature in absolute degree Kelvin. And this works for the ideal gas, this ideal gas equation. Now, what I want to do in this observation, because we like experiments, I want to set up an experiment. I want you to visualize one experiment and try to understand certain concepts. Okay, the experiment which I want to actually visualize is, my aim is to obtain the boiling point of water, which I abbreviate as BP, boiling point. My aim, I want to set up an experiment to find out a boiling point of a water. So what do I need? I need a water, then a container, then a equipment which will help me in heating, and an equipment which will actually find out heat or the temperature of the system. I do this. This is basically done for the people who like experiments, and mostly students and teachers like experiments. So we visualize this. So I don't over-explain this. It is already clear from this line. Now, so when I do this, if I take a container as a beaker, and if I take a water as a 200 ml water, my container will be a little larger. Then I heat up the gas, and I use one of the thermometer as an equipment for this and start my experiment. Okay. Now, then I do this experiment by varying some parameters. I do this at atmospheric pressure. I take various amounts and I just find out the boiling point in degrees centigrade. This can be visualized, so there is absolutely no problem in this visualization. So if I take 100 ml water, if I take amount of water of 100 ml and start heating, keeping the thermometer in my system, then I see that the temperature in the thermometer shows increase and heating is continued. So I see at 100 degrees centigrade, the thermometer doesn't rise its level, but the heating is still continued. I see bubbles coming out, and I call that as a boiling. So the boiling point of that water, the pure water, if I take 100 ml water, I get 100 degrees centigrade. So I write down the boiling point of the water when taken 100 ml is 100 degrees centigrade. Very, very clearly, I understand that. Okay, there are many things involved, but I will not go into that. Okay, now what I do is this. The second thing I do, the same experiment I repeat. Repetition is very, very important in the experiment. So I repeat the experiment, but this time I change one parameter. It is better to change one parameter time so that you understand the experiment. Don't change many parameters at the same time. So what I do now, I keep everything same, all other things same, but only water is taken now 10 ml. Certain things I may have to change. Now, the beaker which is taken for 100 ml may not be used for 10 ml. So I may use a boiling tube or something like that. So I take 10 ml water and carry out the experiment. The experiment is easy to carry out, and I see that my boiling point again when I observe is 100 degrees centigrade. So what I understand from this? What I understand from this is this. So to carry out the experiment at 10 ml is better. Better because the experiment can be done a little faster. The time taken for the experiment is less. The heat required for the experiment is less. So it's a green experiment. And if the accident happens at 100 ml and 10 ml, the 10 ml is little better than 100 ml. If the 100 ml boiling point falls on me and 10 ml falls on me, the accident severeness is little less in 10 ml. So what I understand is whether I take 100 ml or 10 ml, the boiling point of water is 100 degrees centigrade. So I write down the boiling point of a water does not depend on the amount of the water taken. That we call as the boiling point is macroscopic property. The boiling point is macroscopic property. It is also called as intensive property. It is not an extensive property. It does not depend upon the amount. So whether I take 100 ml water or 10 ml water, it is immaterial. The boiling point is the property of the water. It is not the property of the amount. Okay, so that's very, very interesting. So I learned that it's an intensive property. It is not an extensive property. And I also learned one more thing, that smaller is better. So when I do the experiment at smaller level, it is better. It is little bit green experiment. 100 ml takes more energy, 10 ml takes less heat energy. Therefore, I call this as a greener experiment. So 10 ml water to find boiling point is a greener experiment. It's a green experiment. And I learned that smaller is better. Because I learned that smaller is better, so I try to reduce the amount and do the experiment. So I take 1 ml water. Now when I take 1 ml water, many things change. My container may change. My heating equipment may change. My heating process may change. I may have to handle very carefully now, but again, my boiling point will be 100 degrees centigrade. Very interesting. The answer remains same. Again, I learned that smaller is better. Smaller family is a better family. Okay, one can handle it properly. A smaller conference is also a better conference. A larger conference is not a good conference. It will not serve the purpose. Now, because I learned that smaller is better, now I take 0.01 ml water. Because I learned that smaller is better, I still take a smaller amount of water, which is 0.01 ml. And then technology will change. I have to be very careful now with the technology. What is my container? What is my heating? Can I take a thermometer of heating equipment? Do I need to dip it in the system or it should be outside the system? So there are many things involved. But what I'll do, if I do this experiment very, very carefully, again, I'm expected that I will get 100 degrees centigrade as the boiling point. So even though I learned smaller is better, now I know smaller is difficult. Okay, this is the way people actually go to smaller and smaller. Nanotechnology is a very, very important word these days. People want to do everything at a nano thing, but handling nano is also difficult. So smaller is also difficult. Now the problem is this. If I reduce the amount, go down like this, 100 ml, 10 ml, 0.01 ml, then maybe 10 raised to minus 3 ml, and so on. So what is the smallest amount of water I can take for the experiment? Can anybody answer this question? In the chat box, you can write, what is the smallest amount of water I can take so that the boiling point will be 100? Anyone? You can just write in your chat box just to make it interesting. Just to know that whether people are attending. What is the smallest amount of water I can take so that my boiling point is 100 degrees centigrade? 0.01 ml already we have taken. See, if you take smaller amount of water, then my technology changes. So technology has no problem. I can do the technology change. I can carry out the experiment very, very carefully. And then I will get 100 ml. So I see that it's difficult but possible. Smaller is difficult but possible. So I'll go beyond. Yes. So the smallest amount of water, people thought, one student said, the smallest amount of water which can be taken is one water molecule. So can I take one water molecule? Yes. So if I take one water molecule, will I find a boiling point 100 degrees centigrade? That's a question, very, very important. The smallest amount of water is one water molecule. The smallest number of students in the class can be one student. It cannot be half student. It cannot be 1/4 student and things like that. So the smallest amount is one molecule. There's a difference between, yes, one molecule and 1 ml is a huge difference. Okay, very, very important. So when I say macroscopic, I'm talking about large number of water molecules. And these experiments are actually carried out at large number of water molecules, where we use a thermodynamics. So one molecule, once you understand one molecule, it is not possible. One molecule cannot boil. It is not possible for one molecule to find a boiling point. Boiling means what? The boiling means the hydrogen bond between the two water molecules is broken and one of the water molecules goes into gas form. But in one water molecule, there is no hydrogen bond. Therefore, it cannot boil. So once we understand that, it's very, very important. Okay. So one student, boiling is like fighting. When water is boiling, that means water molecules are fighting with each other. Bonds are broken. And one student cannot fight with himself. It is not possible for one to fight. So for fighting, you need more than one. For boiling, you need more than one. For hydrogen bonding, you need more than one. Okay, so that's a question in theory. How many molecules? That's a big question in theory. Okay, therefore, when I say, when we do experiment, we talk about molecules, many molecules. When we do theory, we talk about a single molecule. So that is what I want to make it clear. So when I'll be talking on theory, I'll not be talking on experiments. Experiments will be done on many molecules, macroscopic. I'll be talking on one molecule, where I'll be talking on a macroscopic, and in one molecule I'll be talking on microscopic. So that point I want to make it very clear. One molecule will have properties not like boiling point, melting point, crystal structures, density, all those properties will not be there for one molecule. So here our talk today is for one single molecule, what we can study of single molecule. So here we will not be talking about such a macroscopic equation we learned in 11th standard. Okay, so I go to the next now. So when I talk about one molecule, I'll be talking on theory. So theory, I'll be talking on Schrodinger equation. So very important. This is Schrodinger equation, which is time independent. Simple. Time dependent Schrodinger equation is a little bit difficult to study, but we study time independent equations. So there are two equations here also. One is the ideal gas equation, other is the van der Waals equation, real gas equation. Real gas equation is a little bit difficult. Ideal gas equation is a little bit easy. Time independent Schrodinger equation is easy. Time dependent is a little bit difficult. So we study something simple. So there was one popular teacher who was very popular, he used to teach, and there was a fish pond on that teacher by the students. The students said that, the fish pond on the teacher said that, simple repeated, difficult omitted, and that is how the syllabus is completed. Okay. So we are going to only see not real gas equation, we are going to see ideal gas equation. We are going to see not time dependent Schrodinger equation, but we'll see only time independent Schrodinger equation. Very important. Time independent Schrodinger equation is applicable for one molecule, where the properties of the one molecule do not depend on time. So water molecule, whether you study today or tomorrow or after 100 years, the properties will remain same. Properties of a single water molecule will remain same with the time. Therefore, we study time independent Schrodinger equation. Okay. Little bit more for teachers and students. Okay. So we study molecules in thermodynamics. Macroscopic we study in thermodynamics. We study in experiments or in kinetics. This subject, thermodynamics, is well understood. It's developed long back. In 1970 to 1980, this subject is developed. Okay, and then we study this equation and the real gas equation. Now we want to study molecules. Molecules are studied, single molecule is studied in the subject called quantum chemistry. This quantum chemistry is developed just around 100 years before. So single molecule is studied recently. Many molecules are studied earlier. So very important to know. Actually, many molecules must be difficult and single must be easy, but it is difficult to study a single. That's what we learn. So single molecule means quantum chemistry. Recent topic, thermodynamics, kinetics, experiments, all the topic. So this is where we study this equation. It will be very clear to us. 11th standard, this becomes maybe BSc or MSc. Now even today, teachers are afraid of teaching this. And teacher find PV is equal to nRT equation very simple, because more familiarity with the equation. Now if you see this equation PV is equal to nRT, there are actually 5 symbols, 1, 2, 3, 4, and 5. And there is equal to sign which is common to both. And here there are actually 3 symbols, 1, 2, and 3. This psi and this psi is same here. So there are only 3 symbols. So this equation contains 3 symbols. and this equation contains 5 symbols. But teacher finds this easier and this difficult. So I'll just try to put some light on this, okay, for many of us. And you can stop me at any point or you can ask me questions, no problem. Then, so I'll study this equation first, just try to see this, because this equation is taught in 11th standard. PV is equal to nRT, something very, very important missing in this, I just want to emphasize that. Even though we know this equation, we do not know many things. So P, what is P, what is V, what is N, what is R, and what is T? So let us try to understand this. So I'll put one equation, another one. I'll try to make it a little bit simple. I will put S here, S. I type S there. And I type that S on the either side, both the sides. And this S I will call S correspond to system. P is the pressure of the system. V is the volume of the system. N is the number of moles in the system. And T is the temperature of the system. R does not depend on the system. System is a gas. Okay, so that's what I'm talking about this now. So you see a car. I have shown you a car and there is a tire. And in the tire there is a gas. So this gas is my system. Okay, and I want to work now. I want to find out what is the pressure of this gas. What is the volume of this gas? What are the number of moles of this gas or quantity? And what is the temperature of this gas? That is what I want to study. And this gas is at macroscopic level. This gas is at macroscopic level. So let us try to understand this now. So when I say, if I want to find out pressure of this gas, if I want to find out pressure of this gas, what I need is a equipment and the person. These two things I need. I need a equipment and the person. This I called as the operator. So this operator, I take my car to the operator and the operator operates on my gas system and gives me pressure and nothing happens to my gas. If you understand this, I'll be happy. So I will just put, there is a P with a hat and P without hat. So this P is a number, pressure. And this P with a hat is a person with equipment. So this comes the operator. So operator operating on the system gives me a number and the system does not change. So that is what is important now for me. So this I write as this. So I write the operator operating on the system and I get a pressure and the system remains same. Now the same system, volume operator can operate and gets me volume. Number of mole operator can operate and gets me number. And temperature operator can operate, get me temperature. So basically this is a eigenvalue equation. Now, once this pressure operator is there, which can operate on the pressure and gives me value, it can operate on any tire. So there can be various number of systems can be different, many number of systems. So if I operate on this tire, I'll get one pressure. If I operate on another tire, I'll get another pressure and so on. So this equation is like just like this equation, just check. So this ideal gas equation is actually like an eigenvalue equation. So this psi corresponds to system, this H corresponds to operator, and this E corresponds to a value. Okay, so when operator operates on the system, we extract a value and the system remains same. So whatever I have shown for P, same thing happens for V, same thing happens for N, same thing happens for T. So actually there are 4 eigenvalue equations in this. So if you actually now compare, you see that eigenvalue equation is very basic in chemistry. It is not only in quantum chemistry. So when you operate for a single molecule, energy operator, you get various systems or various wave functions and various energies, and we start to study a single molecule. That is what I want to do clear, and I think it will be helpful to many of you. Okay, so we study one molecule. Now, what are the properties of a single molecule? Boiling point, crystal structure is not a property of a single molecule. Melting point is not a property of a single molecule. Viscosity is not a property of a single molecule, so on. So what are the properties of a single molecule? The property of a single molecule is total number of electrons, total number of protons, total number of neutrons. That's the property of a single molecule. We say molecule is made up of charges and masses. The molecule is made up of charges, discrete charges and masses. Very important. Then molecular weight is the property of a molecule, which can be actually talked in terms of center of mass. Let me not go into that. Molecular structure is the property of the molecule. molecular structure is seen into two ways. One is called a nuclear structure, another is called an electronic structure. There are two structures. What people know more is a nuclear structure. What I'll be talking today is about electronic structure. Okay, then bond lengths, various bond lengths is also a property of a molecule. Some atoms are bonded, some are not bonded. Bond angles, dihedral angles, lone pairs, bond pairs, and so many. Point group, dipole moment, then HOMO, LUMO, total energy. All these are property of a single molecule, not of many molecules. Very, very important. Okay. Then a properties of a single molecule, actually, if you know the properties of a single molecule, you can guess or you can predict the property of many molecules. So the quantum chemistry can help you to learn thermodynamics. That's what it means. Property of a single molecule can lead to property of many molecules. For example, water molecule, water is a polar molecule. Therefore, water is a universal solvent. Carbon dioxide is not a polar molecule, it is a gas at a room temperature. So a single molecule properties will decide properties of many molecules. Therefore, quantum chemistry helps in understanding thermodynamics. Now the question is that, how do we obtain structure of a single molecule? How to obtain the structure of a single molecule? Because experiments may not be carried out. I may not be able to carry out experiment on a single molecule. Nobody will synthesize a single molecule. Very, very important. Take it from me. Nobody will synthesize a single molecule. People can synthesize in grams. People talk about efficiency. No? People talk about yield. The concept of yield is not there for a single molecule. Very, very important. Now, then once I know the structure of a single molecule, there is something called QSAR or QSR. There are two terms, QSAR or SAR or QSR, quantitative structure relationship or quantitative structure activity relationship. So structure will give the activity to the molecule. For example, if I take dichlorobenzene, the meta, ortho, and para, the structures are different, therefore the properties will be different. Very, very important. Structure will give property to the molecule. So, for example, virus, if I take virus, if I go to single molecule, then because of the structure, it will have that particular property. Now, I will try to focus a little more on the structure of a molecule. This structure can be obtained by experimental method by carrying out on a macroscopic crystal structure, and one can get a structure of single molecule also, no problem. Or it can be obtained by something called ab initio method, theoretical method. Structure can be obtained. This word nowadays is very common. DFT is a very common word in theory now, density functional theory. Ab initio method, you can obtain the structure. Many people who do experiment nowadays do a theoretical calculation to improve the impact factor of the paper. Now the structure of the molecule is talked in terms of Cartesian coordinates. It can be talked in terms of something called bond length and bond angle, which are called internal coordinates. And these structures can also be obtained by something called semi-empirical methods. Huckel-MO theory is one of the semi-empirical methods which you have studied in your MSc or organic chemistry pericyclic reactions. Huckel molecular orbital theory, or MNDO, modified neglect of differential overlap, or AM1 and PM3, these are semi-empirical theory. These theories are not total theory, but they use some kind of experimental parameter to make the theory simple. Okay, it can also give you Cartesian coordinates, it can also give you internal coordinates. I will be a little bit talking on the Cartesian coordinates. Okay, so let me take a structure of a molecule and talk about this. So when I see a molecule, actually, molecule is contained of masses and their positions, various masses and the positions. So for example, if I take benzene, there are 12 masses, 6 carbons and 6 hydrogens and 12 coordinates. If I take methane, there will be 5 masses and 5 coordinates. So every molecular structure is given in terms of masses and the coordinates. So I'll just put few of them here. So now I have here in this molecule, there are 3 masses and 3 coordinates. So this becomes maybe water molecule, depending on which is this atom. This can be CO2 also. Then I'll take another 4 masses and 4 coordinates. So this may be like ammonia molecule. If I take more, then I may get benzene molecule. So structure of a molecule, if you see, you will get only this information, very, very important. What are the coordinates of the atoms and what are the masses of the atoms? So larger mass means heavier atom, lighter mass means lighter atom. It is also difficult to actually get hydrogens located in XRD. X-ray diffraction techniques experimentally cannot tell you where the hydrogens are. Therefore, you have to put some kind of theory behind it to locate the hydrogens using X-ray diffraction techniques. Because X-rays, being the smaller atoms, will not scatter the X-ray to that extent. Okay, so there's a limitation of X-ray diffraction techniques. Now, so if I see a structure of a molecule, we don't like this kind of structure. We like bonds and bond angles and bond length and bond type. So this is called a ball and stick model of molecule. That is we are familiar with. The different color tells that there are different atoms. So ball and stick model is very, very important for us. It's just the object to understand. So it tells you something like bond length, what are the bond types. Then it also tells me the hybridization of a particular atom. We can talk about bond angles, diagonal angles. We can also talk about symmetry of a molecule. So we cannot guess here in this ball and stick model lone pairs and electron density. So these two things, this ball and stick model is blind about the lone pairs and the electron density, which I'll be talking today. My lecture will be on mostly on lone pairs and electron density, how to use it and how to get the structure. Also, this ball and stick model does not tell you which is homo, which is LUMO, which is non-bonding molecular orbital, and so on. So, in organic chemistry, there is a word called frontier molecular orbital. So, homo and LUMO, very, very important concept in that. Let me not go into that. Okay, now, what I'm talking this now? This is a different part of my lecture now. So, I have taken a molecule. A molecule means charges. So, these are nuclei. Nuclei are having positive charges. This is larger positive charge, and these are smaller positive charges. I have taken 4 atoms. Let us not worry whether it's ammonia or not. Now, and this dark portion, what I have shown is some kind of electron cloud. So, molecule is actually a collection of charges, positive and negative. Positive charges are heavy, so they will fix at a position, and negative charges are light, so they will be actually localized or delocalized. Now, what I do is this. So, when I take this, I think there is a mismatch of this. So, when I take this positive charge from long distance to this, then this positive charge, if I take like a tester in the electricity, if I take a tester, test positive charge, then this positive charge will be repelled by these positive charges and attracted by the electron cloud. So I can say that this interaction energy can be given by this. So this will be discrete charges. I can use a Coulomb's law for this. I'll get a discrete charges, the repulsion. Za is some kind of atomic number of the atom, and r is the distance of this charge from this. So I'll get a repulsion from these positive charges, and the negative charges being a continuous parameter, I'll put an integration, and there will be attraction by positive, negative, there will be attraction for this. So I develop some kind of energy equation in this, which is the interaction energy of a test positive charge with a molecule. Something very, very important. This test positive charge will help me to study this molecule. Something like this. So if a lion is sleeping under a tree, and I want to study the lion, whether it is alive or dead, I don't go close to it. I just take a small stone and hit the lion. When I take a small stone and hit the lion, if there is some vibration or there is some interaction, then I know that the lion is actually a live lion. If there is no interaction, the lion is dead. So this is a small test charge which I am helping to study this molecule. And I develop some kind of interaction energy like this. So this is my small positive charge will be repelled by the nuclei, and my small positive charge will be attracted by the nuclei, and I will get some kind of, V stands for a potential energy. I'll get some kind of potential energy for this. Okay. There's one slide missing. I don't know whether it's the next one. Okay, so I'll get this one now. So this interaction energy I call as a molecular electrostatic potential. I'll call this as the molecular electrostatic potential. I have put some kind of formalism, some kind of mathematical equation to study this. I'll just explain you on the last slide. Now this already I know certain things. This is a function of three variables because R stands for X, Y, Z, position. R stands for position. So this is where my positive charge is. So that will depend on this. So this is a function of three variables. Okay. Now the first term will be nuclear contribution as I told, and this will always give positive interaction energy. The second term, so this will give positive interaction energy. The second term is due to continuous electronic distribution, and this will be always negative. So it's a number, positive and negative depending on where your positive test charge is. So it is very close to positive charges, then this factor will be more. Where it is very far, then this factor will be more. So there are two terms which will be actually giving you the value. Then the total value that's generated can be either positive or negative, also zero, because this is value. There is a competition with two values, positive and negative. If these two are same, then there will be zero value. If this is dominate, that is if your positive charge is close to the nucleus, then there will be positive value. Away from the nucleus will be negative value, and this can actually give me positive value, negative value, and zero. So this I have actually very nicely we have explained this in our book, which is an educational monograph published by University Press by my guide, Professor S.R. Gadre and myself. A very nice book. We can go through this. Some of the libraries have this book. This is there on the internet also. So I'm just covering this from this book. This is kind of advertisement for this book. Oh, now, what I need for this? So if I take a single molecule, I can actually get its geometry from ab initio method or Gaussian program or Ganes program or some other ab initio program like that. Then I will have a basis set, which will not actually, I will not emphasize on basis set here today, and then I'll get a wave function. So I will get for a molecule a geometry and the wave function of a basis set, and I can use this equation and calculate this V of R. Okay, then what I do is I calculate this V of R on a grid around a molecule by taking this my positive charge at various places in the molecule and calculate this over a grid. Then I can visualize this. The values obtained over a grid can be visualized in various ways. That visualization I just tell you. So this can be visualized something called as isosurface. They can be visualized in terms of contours, and they can be visualized in terms of pixel plot, or they can be visualized on some kind of predefined surface like a van der Waals surface. I'll just give some picture. So this is a picture of water molecule. The molecular electrostatic potential is visualized this. One can say that, oh, this is a negative potential, and it accounts to like a lone pair, two lone pairs of a water molecule, which cannot be seen in balanced model, in a balanced model. Now, this is a molecule which shows acetylene molecule. The acetylene molecule has a negative electron density localization ring. So the molecular electrostatic potential shows some kind of ring around this localization. So the electron density is a negative on this. The electron density is localized on this negative pole. So you can see either lone pair or the bond pairs. Or you can show a pixel plot. So I have shown some kind of surface, or it can be contours, or it can be on some kind of pixel plot. So if you see a pixel plot, this is one of the DNA bases. So one can study where it is positive, where it is negative, so where the electrophilic attack can take place, and so on. All those things can be studied using this electrostatic potential. Now, if I see some negative area here, I will actually like to see where the negative area is concentrated, which is the point from where it starts. So that's very, very important for me. So we talk about this. So this electrostatic potential can help us to study a site of electrophilic attack, nucleophilic attack. Okay, this can also one can help to study lock and key mechanism, which molecule fits with which molecule, where fitting can be good, and all these things can be studied with this. Okay, so electrostatic potential is an effective tool for exploring also the various intermolecular interactions in the molecular structure, there is a subject called water molecular clusters can be studied using electrostatic potential. Now, this molecular electrostatic potential can be also calculated experimentally by using the experimental electron density values obtained from XRD. So it can be done theoretically and experimentally, and correlation can be obtained. Now, we want to study a quantitative information, not only which area is positive, which area is negative. We want to study actually where the point is the maximum negative or maximum positive, things like that. So we study this in terms of critical points. This is a little bit mathematical based, but I will not go into details. But the critical points can be actually located and studied, and we have some definitions of ACM and degenerate cities. So I will skip this a little bit more mathematical, but if somebody wants, I can explain it personally. Okay, so we study a topography of molecular electrostatic potential. What is the meaning of topography? Topography means this. So if you see a topographical map of India, that means you see only mountains, rivers like that. So in the mountains, rivers like that, where the height is more, where the height is less, and so on. So you know that the Kalsubai is the highest peak. So we are very proud. It is in Maharashtra. So people try to climb there. Then there are rivers, then there are lakes like that. So topography can actually tell you where the electron density can be maximum, where it can be minimum, and so many things about that. It is given in terms of two parameters. Okay, let me not go into this. Two parameters. So one is given whether it's a minima, maxima, and whether it is a deep or not. So normally 3 plus 3, if there are two parameters, one is 3, and they function of 3 variables, and all 3 eigenvalues are positive, then we say minimum. So the electron density is like a minimum, energy is minimum, and then where the energy of interaction of that positive charge is maximum, or it is either saddle of this type or that type. So then, these topographical features of NASP can be used to study various things. So it is found that actually it is proved, let us not go into details, that maxima cannot be seen in NASP topography, but there can be minima. Lone pair can be seen through some kind of 3 plus 3 minima. There are bonds. No, normally when you see bond in chemistry, if you get a structure through XRD, you can only calculate the distance between two atoms. You really don't know whether there is a bond or not. But the electrostatic potential can tell you whether two atoms are connected and whether there is a bond or not by some kind of 3 plus 1 subtle point. Okay, ring can also be shown by this. And there is for onions, one can actually have some kind of fixed size and shape. So for the onions, can be described by this. Okay, so let me see this. Now, if I take H2 molecule, it will not have any lone pair or anything, but exactly in between two atoms, I see a bond CP. This bond CP is seen, and for M2 molecule, what I see is for M2 molecule, I see one critical point actually in between two nuclei, and then I can say that there is a bond, and I can see one for lone pair of nitrogen, other for lone pair of nitrogen. So the pair of atoms, you will see, I will see here 3 minus 1 critical point. I will see here 3 minus 1 critical point, which indicates that these two atoms are bonded. And I will see here 1 3 plus 3 and 3 plus 3 here, which indicates that there are lone pairs, the negative value minima. Okay, now one more. If I see ammonia, then I can see these bond critical points here. Then I can see a lone pair here. So that is very, very important for us to know, for me to know whether the bond critical point is closer to nitrogen or closer to hydrogen. That will depend on the polarity of the bond. If the bond is covalent, then it will be different. If the bond is polar, it can be a little bit different. This can shift either to hydrogen or to nitrogen depending on what is there at nitrogen. If I see water molecule will show 2 bond critical points and 2 lone pairs, and these 2 lone pairs will be connected by some kind of another critical point, which is not equal to bond critical point, which is shown different here. Which I see all these things. So it is a nice question to ask. This bond critical point here, one needs to find. If I change the hydrogen by chlorine, whether it comes closer to the nitrogen or goes away from the nitrogen. So that effect can also be studied by putting some kind of inductive effect into the process. The lone pairs can also be studied like that. So this is a point where the positive charge feels happy, where the positive charge interaction energy is very, very less. Okay. Then, if I study ethylene molecule, other than the bond critical point, I have just shown you something. There is some electron density cloud which is negative here and which is negative here, which we see normally. The electron cloud for ethylene is like the negative cloud there and negative cloud here. So the electrophilic attack can be taken either this way or this way, because both the sides are equally probable. We can study this. Also, one study this. What is the distance between the point of starting point here one can find, and the starting point here from the bond, depending on what are the substituents like that. Okay, so we can see a bond negative value minima localized here. One more thing I'll show you. So if you take benzene molecule, this is a ballistic model which I have shown you, ballistic model, but there is a negative or minima corresponding to 6 double bonds. For ethylene there is 1, therefore for benzene there should be 6. So there are 6 minima here and 6 minima here, which when are connected you get a negative cloud density. We can see a sandwich model for benzene very nicely through molecular electrostatic potential. Okay, so these are actually, if you see this is a color picture. This is just where the critical points are. This is shown. So these are minima. This is a ring critical point, and there is a minima connected by several points, and these bonds connected by several points can be seen. Okay. Then I show maybe I have taken one of the bases, DNA bases. Now you see DNA bases. It contains nitrogen and oxygen, which actually have some kind of negative contribution due to the lone pair. So one can study the lone pairs here, and one can see DNA bases and their interaction through that. And which is the deeper minimum? Whether this matter will correspond to a deeper minimum, or this matter will correspond to deeper minimum, and based on that we can have correlation of this. Okay, so we find that G5 is a deeper minimum than G8. So if electrophile comes, there are 2 minima for him. So electrophile will actually attack here, the G5 and not the G8. So N7 will be like protonated or alkylated. That correlation can be done. Very, very useful information for this. Now one more. Now you see here, for ethylene molecule, you see 2 lone pairs here. One this side, one this side. So if you see a double bond, this is a double bond. So if you see a double bond, you are expected to see one lone pair here or one negative charge cloud here. But because now there is symmetry, both of them are same. So here, because the lock structure is locked, both the sides are not same. So if I want to actually put some kind of addition to this double bond, which side will be deeper? Whether this or this depends on this R1 and R2, and this can be studied with this. So this side is called as syn side, and this side is called as anti side. Depending on R1, R2, one can see which side will be protonated faster or better, which will give maximum yield, and can be actually supported by some kind of NMR. Okay. Then, so this is what I wanted to tell you for the electrostatic potential, little bit faster. And then what we did recently is this: we can study something called a charge model. Charge model is a different concept. Many people are developing charge model for some solvent molecule to treat a solvent. So if I produce a charge model, which actually gives me a topography of the molecule, it will be better using some parameters. Okay. So then let me not go into details of this. Okay. Based on only charges, one charge here, one charge here, one charge here, and put one Gaussian so as to get this bond pair, these 2 bond pairs and the lone pair, and that can be celebrated as a charge model. We published several papers on this, but I'm not able to explain you here in this lecture because of time. Okay, and as I said, this can be useful for a solvent interaction in average method. Okay. Then, so what I'll do is I would like to acknowledge for this electrostatic potential work, not the earlier work, Goa University, my guide. Then for the funding CSR, and one of my supervisor in USA, Levinsky from Jackson State University, and then same thing here. Then this is my contact. If you have questions, you can send me a mail, or you can call me and ask me. You can ask me here also. Purposely, I am giving my phone number and my email address. This I call as e-learning. Messaging through email is e-learning, and directly calling is a distance learning. So this is a very, very basic definition of a distance learning and e-learning. Then in Goa, we normally say, thank you, Miss Devare Karo. Thank you very much, sir. Over to you.
Now the session is open for question answer. Audience, if any question, please ask. Thank you, sir. I think no question from audience. Thank you, sir. Professor Shirsat, sir, for sharing your knowledge with us. It was wonderful talk. Hope the participants will be surely benefited by this. Finally, I am humble and grateful to convener and organizing secretary of the national conference for giving me the opportunity to chair such a wonderful session of national conference. Thank you one and all. Now over to Itanki.
Thank you, ma'am.
Rajita.
Thank you, ma'am. That was really an enlightening talk. Thank you, sir, for sharing your knowledge with us about topography of molecular electrostatic potential. Your address has paved way to understand the concepts very well. Thank you, Vandana ma'am and Vikas sir, for introducing.
1 minute. Participant asked, a single molecule will be boiling point remain constant. So I just this is actually a single molecule. There is no concept of boiling point. Single molecule does not boil. There is no hydrogen bonding to be broken in the single molecule. Okay, that's what I wanted to tell you. For single molecule, properties are this boiling point, melting point are the properties of thermodynamics, macroscopic. Okay, they have limited. Only when you have a large number of molecules, such a property exists. For a single, it doesn't exist. For example, I told you that a single person cannot fight with himself. If he fights, then there is a hospital in Thane, I think. Then he goes to Thane for that treatment. Single molecule, no boiling point. Thank you.
Thank you, sir. Over to you, Kavya. Thank you, ma'am. Over to you, Kavya.
Hello, everyone. I, Miss Kavya Kohli.
I, Seema Pal, are here to conduct the poster presentation session.
A poster is medium community to communicate your research or your understanding of a topic. Well, it is said by scientist Albert Zent that research is to see what everybody else has been and to think what nobody else has thought.
Here at virtual conference, we live and die by a communication success and failure. So it is with special excitement that I am pleased to welcome Dr. Rajendra sir as a chairman and co-chair Dr. Prahlad Bag sir for today's e-poster presentation.
We would now start with the poster presentation. However, due to paucity of time, we would request the presenters to please limit their respective presentation within 3 minutes. Bell would be rung at the end of 2.5 minutes. All the participants are requested to kindly note of it. Now, I would request Subhajit Haldar, Doel Bhattacharya to present their poster on potential application of surface modified chitosan derivatives. Over
Good
to
morning.
you, sir.
Good morning to each one of you. Please, administrator, please confirm whether my screen is visible or not.
Yeah, it's visible.
Okay, thank you. Okay, so myself, Dr. Subhajit Haldar from Department of Chemistry, Hislop College, and my today's e-poster topic is potential applications of surface modified chitosan derivatives. And you know that chitosan is a very interesting molecule with respect to its functionality. It's a macromolecule, and it's a linear polysaccharide composed of beta-1,4 linked deacylated unit, and also one acylated unit. It is N-acetyl D-glucosamide, and it is having active amino group and primary and secondary hydroxyl group. So because of this presence of amino group and hydroxyl group, it can be functionalized with different polymers, copolymers, and also there may be some graft polymerization. Also, after modification of its surface, we can also use in immobilization of enzymes and drug delivery process and in the tissue engineering. This work has been done in collaboration with Central University Assam and VNIT, all the characterizations. So in my lab, my postgraduate students performed this, and with this, I can say that this chitosan is a very active molecule biomaterial that we can do cross-linking, carboxymethylation, etherification, graft copolymerization, and esterification. So in the cross-linking, we have performed the cross-linking with a hydrogen. And you know that hydrogen is a natural or synthetic polymeric system. And you know this structure is this three-dimensional structure. And this is a cross-linking agent. And this same structure, this same image of chitosan and hydrogen. And we have taken this glyoxal and butyric acid as a cross. Next slide will show you that about the graft copolymerization. In the graft copolymerization, there is a covalent bonding was formed, and if you see that, it is a free radical mechanism, and initiator was APS, ammonium persulfate, in the aqueous medium. Actually, the main aim was to improve the water solubility of the product. Now here you'll see that in case of acetyl chloride, we will get the orthoacylated chitosan. And with different another copolymers like chitosan PMMA, chitosan pani, and chitosan polyethylene glycol, we are getting surface modified chitosan which is having high water solubility. And these biomedical applications of chitosan, this was in collaboration with Central University Pharmaceutical Lab as Assam, and there is some fibroblast growth and biocompatibility because if it accelerates the growth process. And we have received a very important this figure, this nanofibers of PLA. This PLA means this polylactic acid with chitosan, and the process was coaxial electrospin. And it has been found that it is a very important application in tissue engineering. And also drug delivery system and antioxidant and antimicrobial properties because of its easy bioabsorption, colon targeted delivery, and free radical induced grafting. So this is my references, and so this this work has been communicated to a very RSC journal, and thank you all. Yes, sir. What to the administration? Yes, sir.
Hello, am I audible?
Yes.
I just want to ask you whether this is a novel work or it is reported already.
Actually, we have done some comparison study. Like if you see this, yes, comparative study. If you see this is just a simple work, that's a prelims work that I have presented. We have taken chitosan PMMA. Instead of PMMA, we have taken another compound, chitosan pani. We have taken the substituted amine, chitosan polyethylene glycol, like this. We have performed this comparative study of surface modification.
Okay, it is a comparative study.
Yes, it is a comparative study.
Thank you.
Okay.
Okay, next please, Kavya.
Thank you, presenter. Now, I would like to request Archana M. Moria, Dheeraj S. Jha, Anita Goswami Giri to present a poster on production of biodiesel from vegetable oil and fatty acid.
Good morning to one and all. Present over here, myself Archana Moria, TYBSc student from BN Bandodkar College of Science, Autonomous Thane, Department of Chemistry. Now I am here to present production of biodiesel from vegetable oil and fatty acid. Production of biodiesel. Production of biodiesel is a clean burning renewable fuel made using natural vegetable oil and fat. Biodiesel is made through a chemical process which converts oil and fats of natural origin into fatty acid methyl ester. Biodiesel is not a vegetable oil. Biodiesel discovery in 1937 by University of Belgium. Aim and objective to remove the literature survey for the development of a technology in relation to the biodiesel, to isolate the biodiesel from vegetable oil and fatty acid. Now, methodology. In methodology part, I have to work the sodium methoxide is add the methanol. Sodium hydroxide add the methanol in transcriptification process. The strong acid as a used catalyst. As in the present reaction, after adding sodium hydroxide in mango sweet kernel oil, it is burned 20 minutes. The absorption of light is done by adding ethylene glycol at high temperature. The segregation of layer biodiesel and glycerin was observed at 25 to 30 minutes after breeding. After 8 to 10 hours, glycerin was separated from the biodiesel. This methodology we can use to prepare the production of biodiesel. Results are in a vegetable oil, higher oxygen content allow biodiesel to burn completely. Biodiesel color are golden to brown, boiling point 350 to 350 degrees Celsius. Conclusion are the biodiesel prepared from vegetable oil with esterification method. We can use heating, lighting, power and transport method. Transterification reaction is cost effective, time saving and economical variable reaction. I would like to thank Dr. Anita Goswami Giri ma'am and entire chemistry department of chemistry to giving me opportunity of present my poster presentation. This is my reference. Thank you all attention and listening to me. Thank you all.
Thank you, Archana. One simple question: whether this biodiesel is cheaper than normal diesel?
Biodiesel has cheaper diesel. Normal diesel has cheaper diesel.
So, which you are talking about biodiesel, right?
Yes.
So, is it cheaper than normal diesel?
Normal diesel.
Yeah. So, have you checked the price or cost effectiveness of biodiesel process?
Cost effectiveness.
It is very simple question: whether it is cheap than normal diesel or not.
Biodiesel has cheap diesel.
You are not getting it. Okay, it's okay. Next one.
Thank you, Archana. Now, I would request Seema R. Pal, Dipti V. Godekar, Tejasvi C. Salekar, Sandeep S. Khandal to present their poster on determination of iron, calcium, potassium, and sodium from organic and non-organic jaggery.
Good morning, all. Myself, Seema Pal, from Institute of Science, Mumbai. My topic is determination of iron, calcium, potassium, and sodium from organic and non-organic jaggery under guidance Dr. Sandeep Kahandal sir. Let's get started. As we know that sweetness plays vital role in everybody's life, but when it comes to sweetness, the very first thing that crosses our mind is sugar, isn't it? Why we always jump up to sugar, ignoring our organic sweet? Yes, organic sweet. You heard it right. Jaggery, which is also known as gur. So our only focus was to determine amount of iron, calcium, potassium, and sodium from various collected samples hailing from UP, Maharashtra, and Gujarat. As you know, highest production of jaggery is in India. It is low-cost sugar, low-cost source of vitamin and minerals, which fulfills our nutritional values, which is rich in iron, prevents anemia. Jaggery varies from dark to light color. Here we have determined Fe2 ions by colorimetric method using 0.5 molar KHP solution and 25% 110 phenolphthalein solution. Further, calcium, potassium, and sodium were determined by FPS method. This is a typical form of jaggery available in market. all the chemicals used were analytically graded of purity. These are the two instruments used. Thus, it can be concluded that homemade samples are rich in all elements in comparison with commercial samples collected for present study. One thing is to be noted that the element sodium is taken up from soil during cultivation period, and its amount depends on type of soil. This is the result we obtain along with the graphical representation. You can see here, iron was found to be maximum in Banda and minimum in Pune, Satara and Gujarat samples. Calcium was found maximum in UP and minimum in Satara. Likewise, sodium was maximum in UP and minimum in Satara, and potassium was maximum in Banda and minimum in Sangli. So the sample from Shahganj and Ahmednagar were moderate in all amount of elements. These are my references and acknowledgements. Quit sugar, let your taste buds enjoy jaggery. Thank you. I'm done with that.
Yeah. So you have studied the geography also, right? Your geographical data says that at selected areas or selected geographical conditions, there are different types of iron or these contents are there. Similar study, yeah. So similar studies are done somewhere.
Yes, sir. We have some references where this study was done, but not actually the way we done.
Okay.
Because it was a mini research project. So I collected the samples which were made from my area, and some of the samples were collected from a guidance area. So since it was a mini research project, so it was not that financially that stable.
Okay, so there is one idea actually. You can study the soil samples.
Yeah, definitely. We'll consider this in we have to study this again.
Yeah, and you can connect it. Yeah, you can connect it to your now going project. So that will that will be added advantage for your paper.
Yes, sir. That is in store for further.
Good.
Thank you, sir.
Next, please.
Thank you, Seema. Now our next presenter is Tanvi P. Shirgaonkar, Tejaswini M. Salgaonkar, Pritesh P. Kakde, Smita K. Sonavne, Trupti Londe. They are presenting their poster on estimation of fluoride ions from different water samples of nearby water bodies using calorimeter.
Thank you, Kavya.
Seema, please stop your sharing.
Sorry, ma'am. Yeah.
Tejaswini, your mic is not on.
Sorry. Good morning, everyone. We Tejaswini Salgaonkar and Tanvi Shirgaonkar here to present a research paper on estimation of fluoride ion from different water sample of nearby water bodies using colorimeter.
Abstract. In the context of human health, fluoride is mainly utilized to improve dental and skeletal health. Wide range of edible water from Thane district towards Konkan. Sources used are hand pump, lake, well, and tap water. Qualitative analysis was carried out for the fluoride ion present in the standard fluoride solution by calibration curve method. Various concentration of sodium fluoride solutions were treated with zirconium nitrate and alizarin red reagent to form yellow-orange complexes.
Introduction. According to the World Health Organization, recommendation limit of fluoride in drinking water is 1.5 mg. The maximum concentration of fluoride in drinking water for children under 6 to 8 years should be 0.6 mg, and the limit for older and adults should be 1.0 mg. Fresh water concentration are usually lower, ranging from 0.01 to 0.3 ppm. Fluoride deficiency can lead to tooth decay and possibly osteoporosis.
Methods. Colorimeter follows the principle of Beard-Lambert's law. Whether zirconium nitrate salt is added to the solution of alizarin, wine red color complex is formed. Results in the series in the color for wine red to yellow orange. Concentration of fluoride ions is inversely proportional to absorbance. Where concentration of ion increases, the intensity of color decreases.
Shown graph represent the amount of fluoride present in water which was collected from different sources such as sample A, Salapalli water, B, Konkan region water, C, hand pump water, and D, of tap water of BN Bandodkar College.
Result, the obtained value of absorbance of sample A is 0.15, C is 0.17, and of D is 0.18, which belongs to 0.7 ppm, 0.5 ppm, 0.4 ppm concentration of fluoride and in the sample respectively, where sample B has shown absorbance of 0.12, which belongs to concentration of 1.6 ppm.
Conclusion, fluoride ion concentration from sample A, C, and D are coming under tolerance limit, and on the basis of amount of fluoride present in water, we conclude that it indicates that their ion concentration is slightly higher than that of the tolerance limit, as this sample was taken from the well which was completely.
Acknowledgement. Author is very thankful to VPMBN Bandodkar College of Science and ACO guide Trupti Londe and Smita Sonavne for helping throughout the experiment. These are some references we used. Thank you.
Okay, I think this is a well-known method for fluoride concentration detector, right? So nice work. Yeah, you can expand your work. You can expand your work. Take more samples.
Yes.
Thank you, Tanvi and Tejaswini. Now, our next presenter is Aprajita Kanodia, Pranali Parab, Dr. Rohini Mandare, to present their poster on recycling and quality improvement of laboratory chemical wastes.
Good morning to all. I am Aprajita Kanoja from IOS. Topic for my presentation is recycling and quality improvement of laboratory chemical waste. Our perform under the guidance of Dr. Rohini Mandare ma'am. Various chemical laboratories and R&D labs do drain their chemical wastewater in nearby water body, which results in water pollution. The best solution on this is following 3R model, that is reuse, reduce, and recycle. Instead of putting wastewater in sink, we can segregate it, but not possible for UG and higher level. So this process, that is chemical wastewater treatment plant, can be used. In the present study, we are reporting a chemical disposal plant which will help for recycling of wastewater, and recycled water can be reused. My study is mainly divided into three parts, that is measurement of water quality parameter before the treatment, and treatment of water using chemical disposal plant. Lastly, testing of treated water for various quality parameters. Analysis was done on wastewater, which I collected from chemistry laboratory of Bandodkar College. Some of the chemical and physical water parameters are studied like odor, COD, color, pH, alkalinity, salinity, flame photometry, etc. Before treatment, the result shows that the water sample is highly acidic and have very high value of hardness. The flame photometry result shows the presence of calcium, sodium, potassium elements in large amount. This is my typical setup for the chemical disposal plant. The very first treatment in disposal plant was settlement of the metallic, which was found in the flame photometry and semi micro analysis. So it was selectively precipitated, and the result solution is centrifuged by the same plant by centrifugation. Further, to neutralize the water sample, we used pH for pH of water. We used sodium bicarbonate, which is a mild base. It continued till the pH of the water obtained to 7, that is almost neutral range. After complete process, the parameter of water were tested, and the result is below. Ma'am, down. We tested the treated water sample at the interval of 1 to 2 months, where we found the neutral range of sample. We conclude that before treatment, the pH of water was acidic, which is adverse for environment, and then by treating the wastewater sample, neutralizing it to 7 pH, the adjusted water sample can be used for household and many other purposes, but not for consumption. Also, the water is generated, salt is generated can be used for laboratory testing. So, by this treatment on water, we reuse the water without wasting it. And this is my references and acknowledgement. Thank you very much.
Are you actually implementing this to at your college? This plan?
Yes, sir, at small content we had it.
So if you can come with a good idea, like cost effective, so that can be a very good setup for every
Yes,
lab.
sir, actually, the mini project was this, and it was really very less cost. So at high, we have to consider this.
Because I have seen normally in India nobody is taking care of this disposal and all.
Yes, sir.
So one should really come up with a good idea of disposal of chemicals.
Sure, sir. Well, definitely.
Good initiative.
Thank you, sir.
Thank you, Aprajita. So our next presenter is Pranali Divre, Sangamitra Jaiswal, Anita Goswami Giri on topic Facilitexal Significance and Awareness. Pranali, hello, you there? Okay.
Yes, ma'am. Good morning to one and all. Myself, Pranali Dure. Our research topic name is paclitaxel, its significance and awareness. So the rotating structure over here is of paclitaxel drug having molecular formula of C47H51NO14. Abstract of the topic, paclitaxel is an anti-neoplastic, anti-mitotic, and microtubule stabilizing agent, a chemotherapeutic agent used for treating cancers such as lung cancer, leukemia, ovarian, prostate, and breast cancer, and even AIDS-related Kaposi sarcoma, and many more. The present article is concerned with the advancement and creating awareness among the people, which will ultimately lead to the modifications in the field of pharmaceutical chemistry. Aim and objectives to discuss the significance and advancement in the drug which is having a potential impact on treating various cancers, to evaluate efficacy and toxicity on administration, to isolate the drug from different sources. Introduction to drug. Paclitaxel was formerly sold under the brand Taxol. There are few such brands like Abraxane and Onzol. So basically, drug is responsible for blocking the cells that are present in G2 and M phase of the cell cycle, thereby causing the mitotic arrest. This further stops the cancerous cell growth. As paclitaxel is water insoluble, it plays a role in combination therapy with other anti-neoplastic agents such as Cremer-4-EL, but due to its unfavorable effects, a new delivery system like AVI-007 have been developed, which is comparatively less toxic. So formulation of the drug, that is methodology. Drug has been isolated from natural sources by cell culture method and by other chemical semi-synthesis. So the chart below shows the test solutions and reference solutions that are being prepared from natural source through fermentation and by semi-synthetic methods. Due to COVID-19 spread, cancer patients are having a high risk of getting infection. Thus, it has been hypothesized that even anti-cancer drugs on interaction with other drugs can be used for treating COVID-19. So our purpose of doing this research is to make people aware of significance and of course, knowing the drug itself. Results and discussion. Study and development of drugs have been boosted as there has been an increase in the diseases even after technological development. According to the recent advances, applications of this drug in tumor immunotherapy have been made. It has been seen that it can increase the rate of apoptosis. Conclusion: paclitaxel is a potential natural product and is used at a wide range, so its production and increase in high yield has become an urgent need. Also, clinical trials have been made to define its role in combination chemotherapy. So these are the references used. And now I would like to acknowledge and thanks our research guide, Dr. Anita Goswami Giri, entire chemistry department, and the organizers of ACSSD for giving me this opportunity to present this topic. Thank you all.
Thank you, Pranali.
Yeah, thank you.
Hello, Pranali.
Yes,
Pranali,
sir.
yeah, do you know about the side effects of Taxol?
Yes, it can, due to longer use of it, it can cause hair loss, and also there are further side effects like causing of toxicity in several organs like liver and lungs.
Normally, cancer chemotherapy leads to many side effects. So there is a multi-drug therapy. So if on COVID also if you study on the COVID-19 also, side
Yes,
effects
sir.
is the main. We have to see about the side effects.
Yes, sir.
Yeah,
So research is going on for further to reduce the side effects.
do you
We
know
cannot.
the cost of Taxol?
Sorry.
Cost of Taxol?
Sorry, I'm not getting you, sir.
Do you know the cost? Taxol medicine, right? So
No, sir, I'm not knowing the cost.
yeah, so go for that, and then you will come to know. So what is Taxol? Okay, thank you.
It's actually a brand.
Yeah.
Brand. Under which the paclitaxel drug is sold.
Thank
Okay.
you, Pranali.
Announce
So
the
our-
next, please.
Yes. So our next presenter is Tayyaba Ansari, Dharni Shetty, Khadija Masood. On topic effective adsorption of fluoride on low cost bioadsorbent mixture of charcoal with Melis domestica pale and Coccus nucifera husk.
Hello? Hello?
Yes, you are audible. Please go ahead.
Yes. Please notify that my screen is visible.
Yes, it is.
Okay, thank you. Let's start. Good morning, everyone. My name is Khadija Masood. My research work title, Effective Adsorption of Fluoride Ion on Low-Cost Bioadsorption Mixture of Charcoal with Malus domestica peel and Coccus nucifera husk. My research work focused on relation between adsorbate and adsorbent. It also focused on how adsorptivity rate can be increased. As we all know as a chemist, activated charcoal is a very good adsorbent with high rate of adsorptivity, but it's also cost effective. Our research provides a better use of charcoal and in less quantity. How? We use waste, that is fruit peel waste that already proved to be a good bioadsorbent, and combine with activated charcoal. Will combination of these two increases the adsorptivity rate? With this question, we started our research work and found out addition of bioadsorbent increases adsorptivity rate of charcoal. How? Let's see. Methodology start with finding of standardized solution of respective adsorbent, that is fluoride ion, and standardized adsorbents for the same. We use colorimeter for measurement of adsorbents. As we all know, colorimeter work on Beard-Lambert law. We use 500 nanometer filter for our adsorbance measurement. After standardization, we plot the graph using calibration curve method. A straight line graph indicated that as adsorbance increases, fluoride ion decreases. After that, we use a prepared mixture of different adsorbents of different concentration in equal proportion, and again took absorbance as 500 nanometer. The resultant absorbance for solution treated with mixture of charcoal with Malus domestica peel and Coccus nucifera husk give highest absorbance, double the value of the standardized absorbance. It means the concentration of fluoride ion is half from standardized solution. The resulting graph shows that the amount of adsorbent increases, absorbance also increases. That is, adsorbate, fluoride ion decreases. Our research work can be further studied on wastewater for wastewater management. It can also be further studied for different type of bioadsorbent mixtures. I'd like to thank the Chemistry Department of BPM BN Bandodkar College of Science, Thane, for providing laboratory facilities, required chemicals, and instruments. I also like to thank our guide, Ms. Mita Sonamne and Ms. Trupti Londe, for their guidance. I also like to thank my co-author, Ms. Dhani Shetty, and Ms. Saiba Ansari for their wonderful work and support. Our research hence conclude. What concludes? Waste as opportunity to create green environment. Thank you.
A good, nice presentation. Dr. Prahlad Wag, if you want to ask something, because I am only asking questions.
No, sir, no problem. Any question from audience?
Any
Next,
questions?
Okay. Thank you, Khadija,
Okay.
for this wonderful presentation.
Ji,
Now our
thank you.
next
Welcome.
now our next presenter is Tanvi Shirgaonkar, Tejaswini Salgaonkar, Anita Goswami Giri on topic allium SEPA dye and its application.
Good morning, one and all. Present over here, me, Ms. Tanvi Shirgaonkar and Tejaswini Salgaonkar from Department of Chemistry of EPM Bandodkar College of Science. We are presenting a poster on allium SEPA dye and its application. This research were carried with the perspective of reuse of kitchen waste for dyeing.
Abstract. Efficiency of dyeing cotton fabric with kitchen waste or dry skin extract of allium cepa. The dry skin produces orange brown dye. Allium cepa dye eliminates the use of mordant or fixative during the process due to rich in tannin.
Introduction. Basically, natural dye adds colors to the substance. Such substances with considerable coloring capacity are widely employed in the production of various consumer products. Majority of it is isolated with the plant origin and moderate with the metallic salt. Onion contains various phytochemicals like flavonoids, tannin, etc., which provide excellent source of vitamin A, C, E, and antioxidant. Due to the pandemic situation, college laboratories is not accessible. This dye can be synthesized and applied by the fabric at home also.
Methodology. To prepare extract of dye salts, use the kitchen waste peppery skin of onion. Extraction of dye. 10 gram of dried onion skin placed in a bowl. Added 10 ml of water, boiled and observed the change. Remove the onion skin from spatula from bowl. Added vinegar in water in ratio of 4:1. Immersed pre-wet fabric to 30 to 60 minutes. Let the fabric set in a dye bath. Observe the color and remove extra dye and air dry the fabric.
Structure of dye. The dye stuff present in onion skin is called as palanogonidin. The amount of coloring pigment present varies from 2.0 to 2.5%. This is a molecular structure of it.
Result, waste dried skin of red onion was selected for dyeing the cotton fabric by shibori technique. The diluted dye was orange reddish in color, while after concentration it gave a dark brownish in color. The result we are before and after dyeing the fabric.
Conclusion. The dye is eco-friendly, useful, and employing the waste material for its benefits. Acknowledgement. Author is very thankful to EPM BN Bandodkar College of Science, Thane, and our guide Dr. Anita Goswami Giri ma'am for helping throughout the experiment. We used. Thank you.
Any questions?
I want to ask one question. Why there is a need for this dye, allium SEPA dye? Why can't you use normal dyes?
Due to normal dyes are mostly made of acid or some other chemicals which can affect the skin by creating allergies to it, and where the allium SEPA dye is full of which also prevent body by any allergy.
Okay, so any other examples, if you know, instead of SEPA dye only?
In natural dye,
Yeah.
we can use turmeric, which is also a good, good you can say, and property having good antibacterial properties. Aloe vera, not
Yeah.
aloe
So
vera.
recently, 2 months back, I heard one news. They have made some dye with using cow dung. So
No, sir, we don't have any idea about it.
yeah. It is now in India. It is they are making on a large. They are also central government also funding for this project. So you can go and take some idea from that.
Yes, sir.
Thank you.
Thank you, Tanvi. So our next presenter is Hiba Khan Abhishek on topic a green synthesis, recycling of vegetative waste materials. For Hiba, you can go ahead.
Yes. Abhishek, please share the screen.
Yes. Is it visible?
Yeah.
Okay, so let's start. Good morning to one and all. I am Ms. Khan Hiba, pursuing MSc from Bandodkar College of Science.
Good morning, ladies and gentlemen. Myself, Mr. Abhishek Rajendra, pursuing MSc from Bandodkar College. And we are here to deliver a short poster presentation on our topic, green synthesis, recycling of vegetative waste material for industrial applications.
Here, the vegetable we are using is a Capsicum annum. Capsicum annum is a species of the plant genus Capsicum native to southern North America and northern South America. This species is most common and had a wide application in culinary, ornamental, and in traditional medicine. Though we know that seed of capsicums have various essential properties, but however, we always treat capsicum placenta as a waste material. Have you ever heard about best out of waste? Yes, so we will be doing this only. The main aim of the study is to recycle vegetative waste material, that is capsicum placenta, and using them to fabricate metallic nanoparticles to enhance the quality and quantity of dyes, and can use those nanoparticles as coater for medicines and as a chips for communicating devices. The method that we are used is very simple, like to isolate any natural dye from vegetable or fruit. It is important to do its extraction. Likewise, to isolate a dye from capsicum placenta, we carried out its extraction. Firstly, we collected placenta of capsicum, washed it as to remove impurities, dried at room temperature, grounded the sample, followed by weighing. After that, the sample was taken into flask and mixed it with suitable solvent, that is ethanol water solvent. Heated the flask into water bath for about 60 minutes in the crude dry stuff. For synthesis of nanoparticles, we have used very simple methods. Since we were synthesizing Fe nanoparticle, ferric nitride was used as a precursor. The crude dry stuff was mixed with ferric nitride and kept in dark at room temperature for about 24 hours. After that, solution was centrifuged, followed by a rewashing. The product then freeze-dried and stored in dark container at 4 degrees Celsius. This is how we synthesize nanoparticles. Conclusion, as we know, synthetic dyes are not eco-friendly and can cause harm to environment. They contain a large amount of carcinogen, which thus poses as a health risk. So, by considering green chemistry principle, we use green methods. Natural dyes are less harmful to environment since natural dyes have antimicrobial and antibacterial properties. Natural dyes have high future scope when combined with nanotechnology, which have a wide application in today's world, and the requirement is never ending. So, synthesizing nanoparticles from natural dyes for industrial application will surely going to help future generation to live in eco-friendly environment. Thank our guide, Dr. Anita Goswami Giri ma'am, for guiding and helping us throughout, and also would like to thank Vidya Prasarak Mandal, BN Bandodkar College. Abhishek, please handle question answer session. Thank you, everyone.
Hello.
Yes, sir.
You have prepared nanoparticles. So applied part is you are going to study applied part, right?
Yes, sir.
So it is not yet done.
So, due to pandemic reasons, we are not done any laboratory work till now, but we have done every basic research about it, go on to synthesis and how to do the extraction. We are having all the methods and groundwork about it.
Okay. Thank you.
Thank you, sir.
Thank you, Abhishek. Now, our next presenter is Pallavi Singh on topic modern interpretation of Wittig reaction mechanism. Please, Pallavi, go ahead.
Hello. Yes, you are audible. Yes. Good morning to everyone. Myself is Pallavi Singh. I am pursuing MSc from Bandodkar College of Science. Now I am here to give a short poster presentation on the topic of Wittig reaction mechanism that I done under the guidance of Dr. Anita Goswami Giri ma'am. Now the intro of Wittig reaction in the 1953 Corgu-Wittig discovered compound and another carbon compound that result in the formation of carbon compound with at least one double bond between the carbon atom. Organophosphorus is react with the carbon compound to give a substitute alkene in the transformation called the Wittig reaction. This reaction is named for the Corgu-Wittig who was awarded by the Nobel Prize for this work in 1979. The aim of the Wittig reaction is allow the preparation of an alkene by the reaction of an aldehyde or ketone with the yield generated from the phosphonium salt. Now the phosphoalkenes. Phosphonology pictures the base illustrated by the phosphoalkenes compound with the 3p and 2p pi bond between the phosphorus and carbon that are the isobal to alkene. Phosphoalkenes have evolved from a lab fluorosized to functional materials with the application as a ligand for the transition metal catalyst transformation and as a monomer for the new inorganic polymers. Now the phosphoboranes. Phosphoboranes compound with a
Pardon, hello. Will you please remove this pop-up window? Yeah.
Yes, sorry, sir. Double bond are predict to adopt a band structure unlike as electronic aminoborines and alkynes which are the linear. The oligomerization phosphoborines are prone to oligomerization have they now strictly bulky substituents are employed. Trapping monomeric phosphoborins. Transition phosphoborins can be trapped by the addition of Lewis acid and Lewis base. They can also undergo a 2+2 cycloid addition with unsaturated organic species, alkynes and alkenes. Now the ketone and aldehyde. Diphosphoboridine, one that is undergo 2+2 cycloaddition with the ketone and aldehyde to give a crystalline 1, 2, 3 hyphen phosphoborane oxidant that is 2AE. And the now ester and amide. Treating diphosphoborane one with the ester or amide directly afford the phosphoalkene analog site and acid or base promoted cycloversion. Heating 1, 2, 3 that is 2E with the stoichiometric Lewis acid or Lewis base afford the corresponding phosphoalkyne. Phosphoalkyne 4E can be synthesized in a high yield up to 95% in a one-pot procedure directly in the diphosphodieborane. Computational studies. Preliminary computational studies suggested that the 2+2 cycloaddition reaction is not concurrent, that instead proceeds via an intermediate carbonyl phosphoborane cis adduct. Proposed cycloversion mechanism, that is the intermolecular mechanism, Lewis acid mechanism, Lewis base mechanism. Transition phosphorins are versatile reagent for the synthesis of known and novel phosphoalkenes directly from a wide range of carbonic compounds. Acknowledgement. I would like to express my special thanks, gratitude to my Anita, Dr. Goswami Giri ma'am, as well as the Bandodkar College of Science who gave me the golden opportunity to do this wonderful project on the topic of Wittig reaction mechanism. This also helped me the doing a lot research and I came to know about so many new things and really thank you so much.
Okay, so you are BSc student or MSc student?
Yes, MSc
Pallavi. MSc student.
Yes.
Okay,
Yes.
so you are working on this project?
Yes,
Are
sir.
you Are you working on this project?
Sir, I do literature review on this topic.
Okay, it's okay, no questions. Thank you.
Okay, thank you.
Thank you, Pallavi. So our next presenter is Saurabh Pavli on the topic detection of cathepsin-related compounds. Saurabh, please carry on.
Thank you so much. My screen is visible.
Yes, it is.
Uh, Hello, everybody. Good morning. My name is Saurabh Ramesh Pawari. I am doing MSc. To present my poster presentation on detection of cantharidin-related compounds in Malabaris impresa. Abstract. Cantharidin is mainly found in a beetle family, Melody and Olidarimeridae, insect Caliopetra, which are the natural producer of the terpene anhydride. Most studies to the date have focused on the cantharidin distribution in blister beetles with few reports on recently found cantharidin related compounds, CSR, mass spectrometry, GCMS. The present work reported cantharidin and two CRCs, uh, palsonin and a cantharidiamide from a Malabris impresa stilata in Botin in 1878, which was collected from the Toisakran County, Hamadan provinces, Iran. Ionization provided mass spectra, which was with a characteristic fragments of cantharidin at the peak M by Z 96 and 128. Dimethyl cantharidin at M by Z 82 and 114. Cantharidiamide M by Z at 70, 96 and 127. This is the first time that cantharidin and the two CRC are found on the genus Malabris, which in Bun is a new to the field of. This is the structure of cantharidin. This is a which is an anhydride structure, which is a Deccan structure. This is its IUPAC name. Its chemical formula is the C10H12O4. Its molar mass is 196.202 gram per mole. Its density is 1.41 gram per centimeter cube. Its melting point is 212 degrees Celsius. This is a blister beetle in which a cantharidin chemical is naturally formed. This is which we can see the two peaks at the 96 and 128, and how the extract was prepared. So first of all, the tissues of the sample dye. After freezing 36 days, body fragments were hydrolyzed in small fused test tube using hydrochloric acid at 120 degrees Celsius, fought in order to remove the biometrics and to set the bottom cantharidin free. Cool for a short period, equivalent chloroform, add and shake vigorously 60 seconds. After sample was centrifuged at 3000 and using partial pipette, the organic phase and each tube filter and transfer into a conical 3 gram lip glass vial. And then it is used to, this sample used to take for the detection of mass spectra using gas chromatography. Then conclusion, cantharidin 1 is a natural product which is obtained from the blister beetle. Its chemical therapeutic properties as well as its toxic effect. Cantharidin may be toxic to most of animals and moderately toxic to the humans. This natural product was a aphrodisiacs from ancient times in Greek in China and Greek. Mass spectra of cantharidin can be obtained by using gas chromatography. Its peak 128 M by Z. The chemical structure of cantharidin is a tricyclic compound with decanosystem, which is a colorless, odorless, crystalline substance. Uh, High dose of cantharidin can causes severe side effects. In many countries, cantharidin under narcotics, including United States. These are the references I prefer. and acknowledgement. I would like to thank you, Dr. Anita Goswami, about this project and guide me every time as well as encourage me. Thank you. Thank you very much.
So where this cantharidin is used?
Uh, Actually, it is used as a medicine in some in Afro. Don't forget
Pardon?
that word.
Skin diseases.
In diseases in
For removing warts and all, right?
to increase the sex-related diseases.
Thank you.
Thank you.
Next, please, Kavya.
Thank you, Saurabh. So our next presenter is Pooja Yadav, Neha Khandgale on the topic the application of continuous Grignard reaction in the preparation of fluconazole. Please carry on.
Is my screen visible?
Yes, it is.
Okay. So very good afternoon, everyone. Myself, Pooja Yadav, and my friend Neha Khandagre from BN Bandodkar College, under the guidance of Dr. Anita Goswami, ma'am, is going to give a poster presentation on application of continuous fluconazole. The application continuous method in the synthesis of active pharmaceutical ingredient gain attention in the clean formation of an aryl turbogrenard and its selective addition in the highly ionizable 1,3-difluoroacetone for the continuous synthesis of fluconazole. Now the introduction part will be given by Neha.
Introduction. Continuous method provide access to alternative reaction pathway. Grignard reagents have been widely used on both laboratory and commercial scale and is one of the most common formation of carbon-carbon bonds. However, its application with highly ionizable compounds such as 1,3-fluoroacetone been previously avoided due to the unfavorable side reaction. A significant benefit of this approach for continuous processing was recognized in the ability to carry out both reactions in the single solvent in the absence of solid reaction or byproducts. Objective. One of the major objectives is to improve the process effectiveness and of ingredient by applying the principles of process incentivification, which include the integration of continuous flow reactor. Platform report our efforts to develop a streamlined process for the preparation of fluconazole. We will see the method.
Now,
follow.
Yes. First, we have explored the formation of Grignard reagent at different temperatures and different solvents like tetrahydrofuran and diaglyne, but could not found any expected conversion. But finally, after using 1/8 equivalent turbo-Grignard reagent, gave us a desired product 56% of product yield. Secondly, we have increased the temperature and which did not provide any measurable product. This demonstrated that under continuous flow condition, the chemistry could be carried out with significant reduction in reaction time. Thirdly, we obtained an organo-magnesium reagent, which was further streamlined in line with 1,3-difluoroacetone to obtain intermediate with increasing Grignard input, yield about 90% of the product. There were catalysts on the conversion. With the flow of optimization of the key intermediates out the investigation of fluconazole, fluconazole was obtained by treating the intermediate with 1,2,4-triazole in the presence of inorganic base, sodium carbonate, and methanol in the presence of water. Conversion obtained about 74% with under 4.5 hours of reaction. Now the result, Neha.
In the evaluation of alternative approaches to streamlining the fluconazole synthesis, the focus of our effort turned to intermediate. We considered an approach that would access the intermediate employing a Grignard reaction to install the fluorinated aromatic component rather than alternative orgolanthanide based reagent exists significant precedent for the application of Grignard chemistry in continuous operation and dihaloketone is a readily available fluorinated form. We will see the conclusion by Pooja.
Future work will include the closing gap and applying these principles and technology in other active pharmaceutical ingredients. We would like to thank Dr. Anita Goswami ma'am for helping us throughout this project. Thank you very much.
Have you checked whether it is reported or not? The process you are using
Yes, sir.
continues being
It's just a
applied.
literature review we are doing for our MSc project.
Literature review.
Yes, sir.
Thank you.
Thank you, Pooja. There's a notification for the presenters. Please follow the time rule. You have to wind up till the bell rings. So our next presenter is Namrata Shedge on topic NaCl, a fossil environmentally benign catalyst for the synthesis of pyrazole 4-carbonitrile in aqueous media. Please go ahead.
Is it visible?
Yes, it is. It is.
Yes, yes, go ahead.
Is it visible?
Yes, it is. Please go
Please
ahead.
go ahead.
Hello, good afternoon, one and all. Hello, good afternoon, one and everyone. Myself, Namrata Shedge from MSc Part 2. I am going to present poster presentation on NaCl, a fossil environmentally being catalyst for the synthesis of pyrazole 4-carbonitrile in aqueous media under the guidance of Dr. Anita Goswami ma'am. Abstract: an eco-friendly method for the synthesis of medicinally important class of heterocyclic scaffold 4-carbonitrile phenyl hydrazine and aromatic aldehyde has been achieved at room temperature. Greener protocol of reaction are followed by sodium chloride to accelerate the reaction in aqueous media. Present methodology is a condition-based divergence of synthesis of pyrazole by using simple salt, which offers several advantages like use of aqueous media and high yield of product along with short reaction time. Simple workup procedure, no waste or byproducts. Avoid the use of heavy metals or nanoparticles are the fascinating characteristics of reaction. Materials and methods. Materials are nitrile, phenyl hydrazine, 10 mole percent NaCl, distilled water. Procedure: in a 100 ml of round bottom flask, take a mixture of aromatic aldehyde 1 millimole and malonitrile 1 millimole. To that mixture, add 10 ml of distilled water and then 10 mole percent of NaCl as a catalyst. The reaction mixture was stirred with the help of magnetic stirrer at a room temperature. After 10 minutes, solid precipitate out. This is our novel condensation product. To that reaction, mass added and the reaction was further stirred for the suitable time until the formation of pyrazole takes place. After complete reconversion, a solid crude mass was filtered, washed with distilled water, recrystallized with absolute alcohol, take melting point and TLC. Reaction. The whole reaction is carried out under the aqueous media and NaCl act as a catalyst or reaction product. Aromatic aldehyde is react with malonitrile. It gives novel product is react with phenyl hydrazine. It is the presence of NaCl at room temperature. It gives derivatives of pyrazole 4-carbonitrile. Then discussion on selection of catalyst.
Namrata, please
The
conclude.
study of reaction condition and performance of the reactant was observed by taking aromatic aldehyde, malonitrile, and phenyl hydrazine
resin for the solvent. Completion of the reaction takes place only by stirring the reactant components in the normal condition of pressure, temperature, and light. The selection of catalyst was carried out by applying different categories like simple salt and biocatalysts, since literature survey reveals that such type of catalysts have been carrying out the condensation and cyclization type of reaction efficiency. The screening of catalysts was attempted in two categories. In part, a catalyst reported in literature for such type of novel and cyclization reaction. Initially, reaction performed was to take in the absence of catalyst, which indicates that the product formation not takes place easily. The only novel product was objection. Time is very trace quantity. We carried out the reaction by using mild base potassium carbonate, which was not found to be effectual to increase the reach rate and yield. Bioorganic catalysts like glycine gives 60% yield. Afterward, in part B, the simple chloride salt and alkali group were selected in which HCl and simple non-acidic salts like NaCl, NaBr, and KCl were considered for this purpose. Best results were obtained in NaCl and short reaction time. Then, while by using bromide salt of sodium gives moderate yield of product. Finally, it concluded that NaCl was taken to be the best additive for completion of reaction within short duration along with outstanding yield. Then further quantity-wise screening of NaCl was achieved by performing the model reaction in 10 ml of water and 10 ml mole percent, 5 mole percent and 2 mole percent of NaCl. It is observed that 10 mole percent of NaCl is sufficient to give higher percentage of yield. It is observed that further increase in the catalyst amount of NaCl did not affect the yield and time of the reaction. Hence, it concludes that the combination of 10 mole percent of NaCl and 10 ml of water at room temperature is an ideal condition for the synthesis of pyrazole 4-carbonitrile derivative. Then the result, the reaction clearly indicates that the reaction procedure in high yield and produce the desirable product. It is worth mention that all the pyrazole 4-carbonitrile derivatives that synthesized by this method precipitated from the reaction mixture and can be purified easily by recrystallization from the ethanol. Present methodology is another elegant example of one-pot multi-component reaction in developing green tools of chemistry. Conclusion: Hell developed an advanced protocol for multi-component synthesis of highly functionalized pyrazole 4-carbonitrile derivatives using aldehyde, mononitrile, and phenene hydrazine in the presence of sodium chloride as a easily available reaction promoter. The use of NaCl is aqueous solvent system act as a green reaction medium for carrying out this organic transformation. Present synthetic method includes several advantages such as operational simplicity, uncomplicated work of procedure, wide scope of substrate, and higher product yield using simple salt NaCl. Thank you, sir.
Okay. So this is a reported work you are presenting for poster, right? Namrata?
Yes, sir.
Okay. Thank you.
Yes, sir. Thank you, sir.
So I would request our next presenter, Prajakta Godse, to present poster on green chemistry and catalysis in managed reaction.
Screen is visible.
Yes, it is.
Hello.
It is visible.
Hi, I'm Prajakta Godse. Hi, I'm Prajakta Godse. My poster presentation topic name is Green Chemistry and Catalysis in Managed Reaction.
Prajakta, it's all blank. Yeah, done.
Managed reaction is one of the much more reaction in organic chemistry. The reflection system of is reaction in a multi-component reaction method. In three-component mannix-Rice reaction, ketone, aldehyde, and amine are catalyzed by this effective solvent at room temperature to give beta amino carbonate in good heat. It also describes the most interesting atom, economic Mannix and Mannix type reaction. Keywords: Mannix reaction, water and green chemistry. Objectives: first is structurally forming a variety of compounds by manifestation in water. Second, in water, atom economic synthesis of beta amino carbonate and 1,2 amino alcohol derivative. Third, direction component reaction carbon single concentration of water. Direction: the condensation of carbonic compound having active hydrogen atom when treated with a formaldehyde and ammonia or primary and secondary amine in the presence of HCl gives amino methyl or substituted amino methyl derivative. It is also called as a managed base. The mechanism of managed reaction: first step is formaldehyde react with the amine followed by protonation, deprotonation, and dehydration, resulting in aluminum ion. Second step is ketone, which has alpha hydrogen, gets protonated, deprotonated to totalize an inert intermediate. The intermediate inert attacks the aluminum ion and after deprotonation form of beta amino ketone. These are the conditions of managed reaction. The conclusion is multi-component carried out in water are future in green and sustainable in managed reaction under the selectivity of catalysts, etc. The advantage of the method are simplicity, easy separation of catalysts, and high yield. It is therefore expected that new application of managed reaction in water and also using the other green condition acknowledgement. I would like to express my special thanks of gratitude to my teacher, Dr. Anita Goswami ma'am, and Dr. Reynish ma'am, who gave me a golden opportunity to do the wonderful project on topic is green chemistry and catalysis in managed reaction, which also helped me in doing lots of research and I came to know about so many new things. I am really thankful to them. This is their references. Thank you.
Thank you, Prajakta. Any questions, sir?
Okay, so this is reported work. One should cite the reported paper.
Yes, sir.
Yeah, so that is the big thing. You should cite that paper, right? Thank you.
So our next presenter is Sham Karali on the topic catalytic Friedel-Crafts alkylation reaction. Sham, are you here?
Please take next one. Please
Yeah,
go
sure.
next.
Yeah, sure. So our next presenter is Nashra Khan on the topic determination of adulterant present in milk sample.
Yes.
Good afternoon, one and all. Myself, Nashra Sarfraz Khan from MSc Chemistry Part 1. I am presenting a paper of author Niti Gayak on the topic detection of different adulterants in different milk samples. The study is carried out keeping in view the recently emerging concern of adulteration of natural milk with various illegal substances to increase its marketability and which gives indirectly an adverse effect on human health. Where milk in its natural form has high food value, it supplies nutrients like proteins, fat, carbohydrates, vitamins, minerals, etc. Also, the important one being lactose, whey, and mineral salts. Casein and fat globules give milk most of its important physical properties, taste, flavors. So such high qualities of milk is one of the key reasons that why milk is such an important human food. The author has selected 20 different samples of milk and performed 7 different tests to predict the adulteration in the milk. The samples are collected from different areas such as Ghaziabad, Noida, and some areas of Delhi also. The table here listed the 20 different samples of milk and the area of collection. The samples were prepared by homogenizing the mixture of milk and then by taking one by one the samples of milk. The 7 different tests are listed over here. The saccharine test, nitrates test, sucrose test, anionic detergent test, ammonium compound test, sulfate test, and starch test. For each test, the different chemicals were used. For the detection of saccharine test, here, this author has used acetic acid mixture, and after that, the solution was heated. The milk and acetic acid solution was heated with sodium hydroxide to detect the final result, and it was found that saccharine was absent in all the saccharine adulteration was absent in all the given samples. After that, sucrose test was done. So for sucrose test, nitrate test. So for the nitrate test, the author has used a mixture of diphenylamine, which is dissolved in sulfuric acid, and the reagent is then added to the mixture of nitrate. Again, the blue color solution indicates the absence of nitrate test in all the given 20 samples of the milk. Then sucrose test was done by adding resorcinol solution directly to the milk sample, and the test tube showing the absence of sucrose adulteration in the milk also. Anionic detergent test, again, this was performed by using a dye solution and 2 ml chloroform, which gives intense blue color. The intense blue color layer was formed, either upper layer or lower layer. If upper layer was formed, then it will again detect the absence of adulteration in the milk. And if the lower layer is formed, blue color lower layer is formed, then it will detect the presence of anionic detergent in the test. Ammonium compound test was performed by using chemicals sodium hydroxide, sodium hypochlorite, and phenol mixture of 0.5 ml. Again, the test tube showing the result was of blue color. If it detects blue color, then ammonium compound is absent. Adulteration of ammonium compound is absent, otherwise it's present. Then sulfate test was performed by using chemical of barium chloride solution. It was found that out of 20 samples, in the sample number 6, that is Varka diary, and sample number 18, Vishnu diary, sucrose test was found, sulfate test was found to be present, and rest all again absent. Last, starch test was done by using iodine solution. Again, in this solution also Varka diary test and that Vishnu diary was found to be positive and rest all again negative. The conclusion was that out of 20 samples, only 2 samples were found to be adulterated with sulfate and starch. And also this analysis came to the conclusion that the packed milk which is served in Delhi NCR is hygienic, as no adulteration is observed in milk samples of packed milk. Thank you.
One question, is there any method to detect the excess of water in milk?
Yes, lactometer test will detect the detection of excess of water in milk.
Excess of water, right? Yeah. Normally, how many percentage starch is there in milk?
5%.
5%. I think it should be around 20 or 25%. Thank you.
Thank you, sir.
Thank you, Nashra. So our next presenter is Manali Sonkar on the topic study of synthesis of peptide-based vaccine. Manali, please carry on.
Yes. Is my screen visible?
Yes, it is.
So hello everyone, I am Manali from MSc Part 1. I am presenting a topic peptide-based synthetic vaccine. So introduction, the vaccine is made up of using the live or inactive microorganisms. So central idea is the proper selection of peptide antigen for a vaccine efficiency. Then we have to knowledge about the pathogen life cycle, host entry and survival mechanism.
So we discussed how the vaccine works. So first we introduce the antigen from the vaccine. Then it is accepted by the antigen presenting cell, that is the dendritic cell. Then in the cell, the endocytosis process happens. Then it goes to the MSC1, which goes to the CD8 plus. Then it produces the cellular immunity response. Then it goes to the MSC second class second. Then it goes to the CD4 plus. Then it forms the beta cells, which forms beta helper cells and beta plasma cells. So beta helper cells form the antibody. So antigen antibody complexes form, and this from this the body can find out how to react with fight against the virus. So for this methodology, we perform the chemical synthetic peptide, which is simple and cost effective. So choice of epitope is important. We choosing the protein of interest. Then at first we need to find out the epitope. The epitope is highly conservative. So we adding the adjuvant, which stimulate the immunity power and protect from the antigen degradation. The choice of adjuvant is many. So we use alum because it is FDA approved. And for a drug administration, we use the oral administration because it expertise is required. So we use a nanotechnology in the vaccine where we use a carbon nanotubes which having the size less than 100 nanometers. So we use aluminum oxide, gold, calcium phosphate for vaccine delivery. So how to design a epitope? So epitopes, there are three types of epitopes: flank, step, and cyclase. The cyclase is used for HIV polytopes. So for conservation, we are acetyling the carbonyl group and amidation to the ammonium group. Then we are conjugating the peptide link to the lipids and carbohydrate. Then we are sequentially modified the molecule. So from the conclusion, we are concluded that the peptide-based vaccine is used for the cellular immunity. This vaccine is used for a small antigen in replace of the whole pathogen. So this vaccine is highly pure, so it is reduction in cost, reduction in toxicity, and reducing the side effects. So these are the differences. Thank you. Over.
Thank you, Manali. So our next presenter is Rutik Jadhav on the topic and alternative dye curcumin extraction method and its application. Over to you, Rutik.
एक मिनिट हा. Am I audible and visible now?
Yeah. Please carry on.
Good afternoon, everyone. Myself, Rutik Jadhav. I am a TIBSC student of Chemistry Department, Bandodkar College of Science, Thane, Autonomous. Today, I would like to share my experience of doing the research work, and you will get the idea about my work. The title of my topic is an alternative dye, curcumin, extraction and its application processes. The first question comes to our mind that why I have chosen this topic, as we well aware about the natural dyes and its limitations. We should think about that by using a natural dyes rather than synthetic dyes, we are able to be closely connected with the nature as it is eco-friendly and recognize its place in all our lives. Another important advantage of natural dyes is that they provide a higher UV absorption in the fabric. Due to this, the interest of researchers is growing various applications of it. Now coming back to our topic, I had chosen the natural dye turmeric, which is easily available in the home. Curcumin is the main component of turmeric, which gives the yellow coloration. The present study deals with the extraction of natural dye stuff from the plant called Curcuma longa and dyeing of cotton fabric. Then to see the optimization of different dyeing conditions like effect of pH, temperature, concentration, and time. For extracting the dye stuff, 10 gram of turmeric boiled with the 5 ml of ethanol at 60 degrees Celsius for 1 hour. After filtration, the crude dye stuff was distilled using oxalate apparatus at 70 degrees Celsius for 3 to 4 hours. concentrated solution was cooled and dry form of dye was obtained. As the pure dye stuff was ready, side by side the scouring of cotton fabric was done by scouring agents like sodium hydroxide and sodium carbonate. It removes all impurities in the fabric. The direct dyeing was carried out by using common salt and Glauber salt. Now to optimize the different dyeing conditions for cotton fabric, for pH, the dyeing was done at different pHs ranging from 3 to 9. For temperature, dyeing was done at different temperature ranging from 60 degrees Celsius to 100 degrees Celsius. The similar conditions were obtained for concentration also and time also. The obtained results we can see in the above picture. We can zoom it out. The maximum absorption coefficient value was found with the 10% concentration of dye in the pH 7 with temperature 80 degrees Celsius and the time taken was 50 minutes. I would like to acknowledge the Lifon Labs Private Limited, Dombili East for giving the opportunity to me to carry out my project. And special thanks to Dr. Anita Goswami Giri ma'am and Vice Principal and HOD of Chemistry Department of B.N. Bandodkar College of Science for inculcating the research aptitude. Conclusion for the work is that this is a safe, cost-effective, and by this we can conclude that the natural dye like curcumin would be the alternative over the synthetic dyes in the future. These are some references from which I have taken some information. Thank you for the kind attention. Thank you so much.
So have you developed the extraction method or is it reported method?
No, sir. It is already reported method, and I have taken some information, and I have done this experiment in the laboratory itself. Means मी ना सर याचं प्रॅक्टिकल आम्ही घरी पण केलेलं आहे आणि फक्त त्याचे डिफरंट कंडिशन्स पाहण्यासाठी आम्ही लॅबोरेटरी मध्ये पण गेलेलो. फक्त त्यांचे जे कंडिशन्स आहेत ना त्याचे व्हॅल्यू यूज करून आम्ही टाइम कंडिशन्स ऑब्टेन केल्या.
Okay, thank you.
Thank you, Rutik. Thank you, Rutik. So our next presenter is Priyanka Yadav on topic optimized chemical synthesis of zinc oxide nanoparticles for antimicrobial activity study. Priyanka, please carry on.
Hello, Seema.
Rutik, please stop sharing.
Hello, Seema. I am audible.
Yes, you are audible. Please go ahead.
Okay, I will.
Just a minute, I'm sharing. Priyanka.
Hello. Can you please share the screen? Who is sharing?
Rohini ma'am is sharing, sir.
I have shared screen. Is it visible?
Yes, ma'am. Yes, ma'am. It is visible.
Yes, ma'am.
Yes, Priyanka.
Priyanka, please carry on.
Good afternoon to one and all present over here. I'm audible. Hello, sir.
Yes, Priyanka, go ahead.
Thank you, Bhabha. Very good afternoon to one and all present over here. Myself, Priyanka Yadav.
from Institute of Science, Mumbai, MSc Part 1. I would like to present my poster on optimized chemical synthesis of zinc oxide nanoparticles for activity study. Has research under the guidance of Dr. Rohini Mandhari. Since we all are aware that nowadays nanotechnology is demanding area of research. For present investigation, we have a synthesized zinc oxide in the form of nanoparticles. The literature survey based on various metal oxide and their uses shows that zinc oxide is very useful and cheap materials, and we can use it for various applications. Zinc oxide nanoparticles were synthesized by using simple chemical precipitation method. My experiment is basically divided into two main steps. One is synthesis of zinc oxide nanoparticles and another study of its antimicrobial activity. First, to synthesize the zinc oxide nanoparticle, for the synthesis, I had selected two different precursors, that is zinc nitrate and the zinc acetate. After synthesis, they were labeled as ZNO1 and ZNO2 respectively. During the preparation, we kept the different preparative parameters constant, such as concentration, pH, and temperature were optimized and they were finalized. For the synthesis of zinc oxide nanoparticles, the zinc source were taken and sodium hydroxide taken, and they were dissolved in distilled water and solution was prepared in 1:1 ratio. From the burette, sodium hydroxide is added to the beaker containing zinc source, which was placed on a magnetic stirrer, and after complete addition, we the zinc hydroxide white precipitate, and it was kept for whole night settlement. And after that, we decanted the excess of transparent solution from the beaker, and we get the white precipitate of sodium hydroxide, which was placed in oven at 110 degrees Celsius for 2 hours, and we get the zinc oxide nanoparticles. To confirm whether these nanoparticles were in nano range or not, we carried out the XRD. From the XRD result, we found that both the nanoparticles, that is ZNO1 and ZNO2, were in nano range. ZNO1 is 37 nanometer and ZNO2 is 24 nanometer. After confirming the size of nanoparticles, we move towards the study of its antibacterial activity. To study its antimicrobial or antibacterial study, we use the well and cup method, and we taken two different strains of bacteria, that is E. coli and S. aureus, which is gram positive and gram negative bacteria. And we found that when increases the concentration of the zinc oxide nanoparticle, we get the clear zone of inhibition or larger the zone of inhibition. Applications of zinc oxide nanoparticles used in various field of medicines, in fungal, antifungal, and antibacterial creams and ointments. Conclusion. Both the nanoparticles were synthesized successfully by simple chemical routes, and they were in nano range. It was confirmed by GCPS data. The nanoparticle ZNO1 is 36 nanometer and ZNO2 is 24 nanometer in size. They show good antimicrobial activity. ZNO2 shows a better result than ZNO1 because of its smaller size. I would acknowledge the Department of Chemistry of Bandodkar College for providing the necessary facilities for carry out experiments. We are also thankful to the Department of Microbiology for providing us antimicrobial activity. We are also thankful to IIT Bombay for providing us XRD data. These are my references. Thank you.
Okay, so zinc oxide nanoparticles are well studied. I just want to ask you, you have used one image there, right? So that you have copied from somewhere. So always mention source of that image taken. Yes. So it's copyright, right? Yes. Yeah. So you should write the source from where image is taken. Thank you.
Okay, sir.
Thank you, Priyanka. Thank you so much to all the presenters. Posters were very informative with diverse topics. With the end of all the presentation, it is now my privilege to introduce our chair and co-chair. As we all know, today's session was chaired by Dr. Rajendra sir, who is serving as Assistant Professor in Organic Chemistry at Dr. SDD Arts Commerce Science College, Wada. since 2014. He is postdoctoral research fellow at University of Sweden, completed his PhD in organic chemistry at University of Pune, and done his PhD in exchange research student at University of Regensburg, Germany. Along with this, they have qualified GATE IIT Bombay CSIR UGC NET exam in 2005. He has contributed major research projects on design and stereoselectivity synthesis of aminocyclitols. I request to mute yourself if anyone is unmuted.
Thank you for my introduction.
He has been awarded the Excellency in Research Award for promoting research activity at Dr. SDD Arts, Commerce and Science College, Wada. Also, I would take this honor to introduce our co-chairperson, Dr. Prahlad Wagh sir, working as assistant professor at VPM BN Bandodkar College of Science. He has done his MSc in organic chemistry at Pune University in 2010. He cleared GATE exam from IIT Bombay, NET LS CSIR UGC Board, NET JRF UGC, and SET examination in 2013. It takes my honor to say he has qualified 6 times NET and 7 times SET and GATE exams in last 7 years. He has published 6 international research articles in reputed journals like ACR, LZY in field of material science and thermodynamics, field of physical chemistry. Also presented 2 international conferences and is working as community member of American Chemical Society. With this long list of his achievements and glory, I would like to request Dr. Rajendra sir to please speak some few words and give remark for the session.
Thank you for my nice introduction. Good afternoon all. First of all, I congratulate the team of Bandodkar College for arranging such a nice poster presentation and conference. And I personally thank Dr. Wagh for giving me this opportunity. So this is my first experience of judging the poster presentation and all. So most of you have presented the reported work. And one thing I want to mention is that about Dr. Anita. So I have seen many presentations where she was there and she has guided the students, and many of them are writing some reviews and all. So at the MSc or BSc level, if you are studying this kind of activity, so that is really a very good activity. By your teachers are really taking efforts to make you better scientist. I think so. So once again, thank you for giving me this opportunity. Thank you.
Thank you so much, sir.
Thank you, Mane sir. Dr. Anita Goswami. Sir, many of us students and their actually situation as need access to the lab, so they have to use alternative methodology, and it is very much required to inspire, motivate, and inculcation of research among themselves, so that they will get many things which we are not accessing in the laboratory as well in the theoretical chemistry. So thought to solid chemistry we will focus on, and hence started with this theoretical chemistry last year for the MSc, because they have their projects and they should know, because after this they might be R&D technician or maybe the head, or next set, and they will be the teacher, future teacher. So thought to get on the channel for them. Thank you so much for appreciating me. Thanks, sir.
Thank you.
Yes, Savan sir is already with us. Welcome, Savan sir. Anita madam.
Savan sir. Savan sir.
Welcome, Savan sir.
Thank you. I hope I'm audible.
Yes,
audible. Yeah.
Yes, audible.
Yeah, I could tune to your this business going on. Last 15-20 minutes I could spare. I was keen to attend some of the papers, so I was so happy to be with you in time. And the delay has helped me to attend some papers. Thank you. Thank you, sir. So, what's the schedule? You think can go ahead.
Hiba and Aparajita, please take the dais.
Yes, ma'am. So here it's time for the most important session, that is valedictory session. I would like to invite and welcome our guest of honor for the session, Chair of the Conference, Principal Captain Dr. Moses College, BN Bandodkar College, and Convener of the Conference, Vice Principal Dr. Ambavadekar Sir, BN Bandodkar College. And our very chief guest, Professor A.D. Sawant Sir, Professor Vice Chancellor, University of Mumbai. I am humbled to address such a wonderful gathering here today, all under the same umbrella of cherishing success. This was a conference which was completely conducted on digital platform due to COVID-19 pandemic. As we know, every year the theme of the conference keep changing, but going with this conference, that is Advance in Chemical Science and Sustainable Development, was remarkable. This theme cover every aspects of our society and our environment. This will definitely going to change chemical science dynamics. Now, I would like to hand over the further session to Aprajita.
Thank you, Hiba. I am Aprajita Kanoja from Institute of Science. I have a very pleasant duty of introducing our chief guest, Dr. A.D. Sawant Sir, the former Vice Chancellor of University of Rajasthan, former Joint Director of Higher Education, Mumbai, and the former Pro Vice Chancellor, University of Mumbai. Yet the occasion demands, and here it is in brief. Dr. A.D. Sawant Sir completed his PhD from Institute of Science, Mumbai. Currently, he is Director of WTERT India, that is Waste to Energy Research and Technology Council, set up by Earth Engineering Center, Columbia University. Sir has published over 150 papers, of which 87 papers in foreign journals. His work has been also published in Encyclopedia of Analytical Science, published by Cambridge University. And also, he executed over 25 research projects, including one from IAEA, Vienna, Austria. He joined the movement of Dr. Rajendra Singh while he was Vice Chancellor at Jaipur, called the first Water Audit Conference in India under his guidance. Currently, he has been appointed as member of expert committee by Honorable Supreme Court as member of civil society to suggest mitigation of flood of Mithi River and improvement of its water quality. As an administrator and vice chancellor, he brought out landmark changes in higher education system. Sir was first to design formula for fee structure and regulation of professional courses in India. Addition to this, Government of Rajasthan appointed him as chairman of High Level Committee for Restructuring and Improvement of High Education. Sir is the recipient of awards from many organizations. He is engaged in transformation of technologies for rural development and was the leader of many academic delegations to various countries and invitee to many international forums like BRICS, IAEA, and several conferences. Not only this, Sir is the Vice President of National Society of Friends of Trees and the President of Society for Clean Environment, Chief Trustee of Institute of Science Golden Jubilee Trust Fund. Currently, Sir is actively arranged with WTERT in advocating and giving consultancy to municipal corporation on solid waste management for converting waste into energy and also recovery of wastewater materials for recycle and reuse. So after this brief introduction, so here I consider it a great honor to welcome Dr. A.D. Sawant, sir, for valedictory function. Please, sir.
Rajita. Firstly, I would like to call Dr. Moses Kole, sir, to invite and welcome our chief guest for this session.
Yes. Good afternoon. Good afternoon. A.D. Sawant, sir. Welcome to the college. A.D. Sawant, sir, has always been a very good friend of our college. Of course, personal friends also. Very good friend and very good well-wisher of our college. I have some fond memories where we have gone to sir's parental house, Vikramgarh, and met his father also. So, sir, we welcome you for the valedictory session of our national conference on the advances in chemical sciences and sustainable development, ACSSD 2021. And you are the right person. I congratulate the team. I congratulate Bandodkar sir and Anita madam for selecting you, for inviting you. You are the right person for this, sir, because of your role played in water and the purity of water. And sir has done some not just paperwork, but also field work and awareness in the villages, so that the villagers or the people getting the water from the rivers get aware of what is being released, what harmful components are being released into the water, and that led to some uprisings and social interactions and interventions of the government, etc. So this is actual work. You are the proper person, sir, for today. I request you to please enlighten us with your learned words, sir. Thank you so much and welcome to our college, sir. Please, Eva,
Thank you,
please.
sir, very much for this nice introduction by you and also the HOD madam. And before I begin, I will just pay a little tribute to a departed soul of my strong associate colleague in the laboratory, Dr. D.P. Dave. Many of you must have heard. The news has just come in.
Sir, you are not audible, sir. Some connectivity problem.
There is some.
Anita madam.
Yeah, I'll message you.
Okay, that's okay. Bandodkar sir. Bandodkar sir.
Welcome, sir. Welcome, sir.
And it's okay. It's okay. About our Bhamne sir also, you please, if you have not informed, just you can make that.
If you do that formality, I'll be happy, sir. If you do that.
I'll
on
do
behalf
it.
of all college.
Yes, yes. Sawant sir, I think he's speaking, but he has not realized that he is not audible.
Yeah.
Because he was mentioning to somebody.
We know already, sir.
Yeah, I just spoke to him. He's connecting himself.
Moses, sir, in the morning, we have 1 minute silence in the memory of Bhamne, sir.
Yes, sir.
Hello.
Yes,
Hello.
Yes,
I'm back in. I suppose I'm back in.
Welcome back, sir.
Welcome back, sir. I said the connections are unstable, so don't worry. There may be pause for all of us for a few seconds in between, because connections are unstable. But I have put a hotspot, so don't worry, lecture will go on definitely. My laptop will not deceive me. I was just referring to the memories of Dr. D.P. Dave, our strong associate in the inorganic laboratory of Professor Muralidhar, very ardent researcher and always believe in applied work that we together were working. So he just got in the bad news today morning, and so he's no more, again, the victim of this pandemic. At the outset, I must congratulate the college.
Sawant sir, just give me 1 minute, Sawant sir. Hello.
Yes,
Sawan
sir.
sir,
Continue, sir.
एक minute. One more bad news is there. Our Professor PG Bamne from Department of Chemistry.
Oh,
He has yesterday. He was from chemistry, so you must be knowing him.
I know.
Again, one of
I've
our strong
been.
hands. Just retired a couple of years ago. We lost him yesterday night, sir.
So sad news. Our tributes to these all great chemistry people, Yeah, so sad.
May their
Anyway,
souls.
the world has to move and we have to go on. So, sir,
Yes, sir.
it is nice meeting you again, our old association and memories. I remember where we began the program and at Bandodkar College, incidentally on the environmental issues. Something like Paryavaran Vahini, the state of India, sorry, Maharashtra and government of India started, and I was a convener, coordinator for Thane district. So we had a wonderful program in Bandodkar College, in addition to many chemistry programs. So all my association with the college is very old because I studied in Thane, I stayed in Thane, I know lots of chemistry and other persons also. So it's nice to be back with this. So we shall really discuss few important things. And I appreciate the development of college from nowhere it began with, and now the Vijay Bhai has worked so hard, relentlessly, and have been constantly involved. There are very few managements who have been constantly involved in the development of college. And from nothing, they have built the empire of the higher learning center at the Thane Lake place, because it's a torchbearer for the entire Thane district. It's being looked at the guiding force for rest of the colleges and maintaining the academic standards and research as well. So I'll congratulate you all for this wonderful organization of almost international conference. So our friend, Director Dr. Bragade and Dr. Moses Kollet, our great friend, they came together, and HOD Bandodkar sir, and convener Goswami, Giri madam, and Gayatri has been always helping them. What is important that you rope into very good people from the Crasto, from the Glenmark, and Zade of high pin type of organic semiconductor. When semiconductor India is doing such a good work nowadays, and it's very, very important organizations, and to introduce students to the organizations like organic semiconductor by itself is an industry, big industry.
So some problems, sir. Connectivity problem, sir. Anita madam?
Yeah. He is again facing a problem. Just give him 2 seconds, he'll come back.
Please check on your side also.
Yes, sir. You're audible, sir. You're audible, sir.
Audible, sir. You're audible.
I know, but why so many interruptions coming? I don't know. It's something wrong from my side. I can't help, but then from your side, please see that things are. So you wrote in very good people like Zodge and Vivek Polshettiwar. I heard him before, the young enthusiastic scientist at TIFR. I'm sure it was a great feast to all the participants getting lectures from people like him and Rajendra Shirsat, So I congratulate you all for, first of all, getting into such a good topic for this conference and inspire the students. And also I congratulate students who have presented the paper so well, and somebody has attempted to even synthesize the vaccine, and in addition to many other things, nanoparticles and all that. Friends, now we are on different platform today. Not we, means the entire world, The title you have thought of this conference is Advances in Chemical Sciences and Sustainable Development. See how appropriately you think that the world is advanced, we all agree. From nothing, we have been able to get at least a potable water in a city like Mumbai and the country, which was not there until late 70s, if you remember. Advances of treatment in even a potable water were not there. But then advances have also brought in the problems. Maybe it is the pharma, chemical industries, nuclear industry, nuclear medicines, cements and fertilizers and everything. Unfortunately, advances have brought in many developments. The countries which are tottering on economy, they have come to some economic platform. People started getting a job and life appeared to be better with the advancements of science and technology and easy access to gadgets, right from transports to anything, people thought the world is becoming faster and better. But now pandemic has told us in every century, this slap is there on the human mind that yes, the development as you go on, but this century it was not expected with so much of the advancement and millions of pharmaceutical chemical industry and understanding of environment. With that, probably had we understood, not we India, we don't blame us Indians, but I blame the human race. Coming to India, half the populations, nearly 800 million people are already having some or the other comorbidity. Environment pollution is at catastrophe. We have made the regulations, and I will come to the molecules which are the most dangerous. Still, knowing that we don't care about it, The simple molecule like carbon monoxide entering into our body with excessive combustions and the concentration knocks out your oxygen from hemoglobin and makes your health fragile. And you get subjected to all problems like pandemic like this and many more illnesses, Do we worry for carbon monoxide? It takes 110 days for oxidations in atmosphere, in natural process. Do we have upgraded our gadgets so that there is no oxide when 325 ppm is a recommended level of concentrations in and the cyclic chain compounds into the aerosol which we breathe every day. Friends, with the development, advance of chemistry, let's not talk of other things. These molecules are introduced in enormous quantity, and that has made the life non-sustainable, I would say. We talk of sustainable environment, but the whole thing is there are now life-saving drugs. At the same time, there are life-killing molecules in the atmosphere. And so we all chemists have to worry about it, So new method, maximum from minimum, the catalysis, the industrial processes. Other day, we upgraded the approach to the ICT syllabus of sustainable chemistry, green chemistry, whatever it is. Students had to be told and taught the processes of industries which does not produce so much so waste, which is so hazardous, and what is good in the environment is finished or destroyed, and then upsurge of pathogens and other proliferations and the pandemic like corona things and many more things can get flourished and into the environmental damage. So let's look into the holistic approach. So our problem is that we produce not only enormous quantity, but in a indiscriminate method. We don't think how many water molecules we just destroy to get one molecule, be it textile or be it bleaching or be anything like, And virgin water molecules are destroyed and resources are destroyed, and that gets back to you. So what is thrown out has become more hazardous than what you have prepared, harness or synthesize. The girl was talking about synthesis of zinc oxide. It's antifungal element, very well known. Your wheat flour contains 200 pp, 250 ppm of zinc, It's a very essential element in almost all food chain. But when we try to synthesize something like, you try to go to the optical whiteners, zinc and titanium oxides these molecules are detrimental in excess in such a way that they can do lots of damage and get associated with easily the other toxic heavy metals in a company or such kind of sedimentation it happens. So we have been talking about toxic metal, heavy metals and all. So producing enormous amount of this has really unshaped the whole structure of a life. And so this is what we have to think of. Even in the laboratory, we are not thinking of the clean environment, which is essentially, we all chemists must think, I would say, it's a criminal if you touch upon the pyridine molecule. It will be criminal if you inhale chromyl chloride. It will be criminal if you inhale H2S in the laboratory in any operations. And don't you think that has been happening regularly? And every laboratory, how much waste is generating is just going to the Arabian Sea. We are not worried about those because we think that it's nothing. And we get satisfied with the purpose of the experiment. But we forget what you have been throwing out of the whole philosophy is now. Whatever you are producing, the processes must be the green. Produce minimum waste and molecules which are hazardous. Effluents and other things are too large things to talk about, but the small emissions, be it a power plant, be it a nuclear power plant, be it a fly ash thrown out, be it a cement plant, be it a fertilizer plant, be it urea plant. You can struggle the Benedict solutions in the reactor. At the same time, when you are producing urea, NH2, NH2, that knocks your throwing into the atmosphere. Health, loss of immunity, and so these molecules are playing their havoc inside and outside the body, and therefore, when you deal with the chemistry and the molecules and advances of chemistry, you'll have to see there is sustainability. Nothing excess that can be absorbed in the atmosphere can be tolerated, and so that results into the ill health of the people. And the worst at the time you are conducting the seminar, you see, the nitrogen dioxides, oxides of nitrogen, for example, it is the outcome of the combustions of the nitrogen, 79% atmosphere. We have been talking about carbon footprint, the carbon atom, and the subsequent molecules and all that. But what is happening to that? The Kyoto summit, everybody has forgotten. Montreal Protocol, everybody has forgotten. It goes on, CFCs goes on. Combustion of the fuel, fossil fuel goes on. We have lip services of the control of the greenhouse gases. But friends, these concentrations I'll tell you, now the pandemic tells wherever the NOx levels are higher, it is a pulmonary problem and people have suffered most of the corona because that's the molecule that bothers you. That the molecule bothers your lungs. That the molecule which will weaken your lungs. Make the entry for a cytokine storm production once the corona finds the entry. Now, if you go on indiscriminate combustions like this, 22,000 tons per day of dioxins are produced right from the even handling of this municipal or solid waste and combustions. What will happen to? If you take care of the IEA regulations and nuclear power plant and see that no tracers are coming into the atmosphere, for which I cannot certify guaranteedly that there are no tracers around into the atmosphere, the molecules of oxygen, the carbon, the cesium-130s, and so on. Friends, I'm very vocal on these issues right from my students' days. As Sir rightly said, I have taken the tajals and fights and the problems in industry with the government. And that has become a habit to ask what wrong is going on, why wrong is happening, And therefore, we'll have to go in a more systematic way. And that has to be taught to the students. We all think the kachra is a kachra and nobody bothers, no government, no municipal corporation. I was telling, if you convert that recycle, reuse and combustion, you can produce the energy equivalent to 20 nuclear power plants from just the kachra that you get in these metro cities of the country. Why we are laughing at China? Not a single material is allowed to go to the West. In China, 400 waste to energy plants against hardly 6 with hiccups in India. Friends, our approach has to be changed. When your student become government officer, they see that they don't become babus. They are sensitive to the science in a bureaucracy, which they don't respect. There is no respect for science and technology in a bureaucracy. Your bridges and repairs can wait till they collapse, because they are looking into budget first, And so look at what the world is going, syngas is in a molecule. What is it? Carbon monoxide and hydrogen. You get it out of just biomethanation, gasification process. Can't we do that? With 10,000 tons of the waste and more hundreds of thousands of agro waste, you can't get into the process of converting that material. For me, it is as good as having a copper wire as a material, aluminum wire as a material, aluminum sheet as a material, or titanium dioxide as a material. Gasification in addition to 10, 20 more technologies. You get a steam, generate power, you can generate fuel, you can substitute natural gas, which is a fossil fuels like, You can get hydrogen for oil refining, you can get chemicals, you can get fertilizers, and you can get so many consumer products from a simple agro or a municipal waste biodegradable. Can you believe? For me, it is just like iron mine, manganese mine, or it is a zinc mine, which are just by process and metallurgy and pulverization and open hearth furnace. I get pig iron, I get this iron and that iron. The same way, I am getting these products much refined and much more costlier, but I have to have mind not to waste any atom or molecule in the material. And till that happens, greenhouse gas concentrations, global warming, it's going to happen. Your CO2 will rise, methane will rise, NOx will rise, and then 18%, 12%, 11% coming from industrial process, agriculture, and fossil. Friends, the world's countries in the world which are developed, they are using right word, they have developed. They don't allow this to happen. We the most advanced state like Maharashtra and Mumbai, we allow it to happen. Not only that, we are not concerning about the material that produce every day in the household. We are only worried about getting good water treated by the chemical processes. At Bhiwandi and Pandrapur, from 130 kilometers water drawn, 5,000 mld per day to city of Mumbai, treated water with lot of chlorination, of course. But resultantly, you all chemists have forgotten, the municipality will not understand. It produces trihalomethane. Trihalomethanes are carcinogenic. We have been talking last 5 years. In addition to cataract problems, they are carcinogenic, and all halides and chlorinations and treatment at Mulund Reservoir. Nobody is listening to these THM concentrations going to the dangerous level in drinking water of Mumbai city. The next generation will not be immune to all this, but they shall be victim to these problems, and no wonder the cases of any diseases, any pandemic, any problem, they are on the rise because we have no respect for the health. While producing the molecules, advances of chemistry, I do understand. You have the CFCs for lot many products which are commercially important, but if that one remains, one molecule can destroy 3 lakh molecule of ozone, why the hell we want to have those CFCs like it? At what cost? With 30,000 times higher potentials of doing damages to the skin and skin cancers. So the world has to learn to shun all these products which are hazardous if you are talking of sustainable development and no pandemics to prevail. And once that, in the cities with the larger density, populations, the vehicular emissions, Delhi, Mumbai, why? 11 and 17 or 18 million vehicles are in these cities, producing what? We take care of the fuel, but in what sense? You got the CNGs and LNGs like, but they are what? Good storehouses of the next generations. Only they don't blacken your face and don't see the black suit, but then the next generation. So combustions at low temperature, the minimum combustion, everybody has forgotten. We don't bother about carburetors, we don't bother burners in the house, and let the combustion go on. And we can inhale any amount of carbon monoxide rather than getting carbon dioxide in the oxygen. From the thermal power stations, and you don't get plenty of the flash, unfortunately. As I said, the babus, they don't worry about, they have been advising to use a fly ash in a cement. Please don't buy that cement. If it has radioactive traces, your bricks will carry the radioactive isotope like holmium. It's also carcinogenic. But WHO talked about it 25, 30 years before, not to use these materials anywhere around you in anything which you get contactable. The government of India says 40% can be mixed into the cement. Whose benefit? We don't question. We never question when 6 shiploads of the cow dung was being imported in this country. And even being government officer, I had to stand on the road and oppose for it. Others were afraid for the job. I did shout. Devi Goenka, myself, we all Soglin people, we could prevent the entry of the methane producing material, the cow dung. Earlier, they're dumping nuclear waste into the African countries. They got awakened, then they stop it, And so is hazardous material like CFCs. Foreign companies wanted to recover the cost of investment, so CFC continued beyond the Montreal Protocol guidelines, So friends, it's not only doing science, but science in planning and administration is very important, So we have gone to the threshold limits of these molecules, which we can't tolerate. The evidence is the pandemic and many other diseases. So the waste generated, disposal method, the green activities, all this has to be. Now let's talk about simple things like, as I said, the municipal solid waste can go for gasifications and get scores of resource material that you can produce, And so when you go for such processes, I think you can minimize the problem that we have been suffering through. Let's go to the simple small synthesis like, and if you see that livolinic acid, delta amino livolinic acid, very important molecules in healthcare. And naturally also for a blood synthesis is very important. If you don't have delta amino in your body, there will be no blood synthesis, you become anemic. So such molecules can be now prepared. They are very important chemically also, health-wise also. They can be prepared from the paper mill sludge, agriculture residues, again I come back to them, and from the municipal waste also. Has anybody even thought of the projects of getting livolinic acid from these processes, and so that don't go for synthetic processes, which is a base for succinic acid production also, is a base also butanediol italic acid route also. Those of you organic chemists can look into this and they can go for. In case of synthesis of polycarbonate, we must abandon the Poisson process. Now, how dangerous the Poisson process is then? And we change it and go for the alternate routes for that. So the hazardous routes of the productions have to be stopped, like synthesis of diphenyl carbamate. Goes on. And the biphenyls are so dangerous, they are carcinogenic, and lactating mothers have to take care of the biphenyls into all their food chains and waters and milk and whatever it is, So friends, these molecules, they are very, very dangerous. So with advancement of the chemistry and chemical processes, attention also has to be paid to. In the process, we don't produce anything hazardous, carcinogenic, teratogenic. And if you work for a better life, let us not produce which will destroy the life. And therefore, whether the reagents or the solvents, the reactions, the conditions, the boilers that you work on, be laboratory, a dust-free laboratory. Can you see that your laboratory assistant, attendant, particular assistant don't sit in the chemical storehouse? We youngsters, we survived so much inhalations for the period of 3 years, 4 years of chemistry or research, 10, 15, 20 years. Please look back and trace out what happened to your laboratory assistants, laboratory attendant in chemistry, and storekeeper who were made to sit in thousands of chemical bottles in the store with his chair around there, a chemical around rather, the chair. What happened to their health? Has anybody traced out? Somebody can study this. If nothing more, at least the tuberculosis they suffered too. So, green laboratory, in this advancement of that, whatever you do, synthesis, including vaccines and material, small, simple techniques, even a radio traces environment, we have been shouting about simple citrate and citric acids. also can bind them not to go for canisters to confine them so they don't go to environment. Simple chemistry of extractions can bind them, Phytoremediations technologies can be used to capture the hazardous molecules, Clean development mechanism can be used in fertilizers and chemical industries, no matter the cost, because the life is costing us like anything. So no emissions are coming out. Somebody has to tell the government of India, no abandoning of CDM. Industries must fit into that. And so that we don't want any emissions into the atmosphere. No, we shall pay the cost for that because we want to have a safe and clean life and no contaminations and invitation to pandemic So this is the new mantras. Begin from your laboratory. The bottle that you handle, you don't contaminate your hand. Those molecules don't bother. You might be doing some advanced research. You might be thinking of forming solid solutions in solids, heating temperature, alpha, beta, gamma, radiations, and the heating phase and furnaces, capturing those, doping all those. But then in a process, stay safe. Don't handle chemicals the way indiscriminately we have been handling into solvents you are using into. Nobody thinks of recovering of the acetol. I mean, many of the solvents now, carbon tetrachlorides and benzene, they have been banned from India, but we have been still using it. But at least go for recovery. No molecule should be allowed to the waste. Store them and distillate them out and separate them out. Use their technology for separations and isolations. So no chemical molecule goes into the environment if you can prevent to the maximum. The advancement of science and chemistry they have been doing. You do with sustainable development. The experiments you have learned over years and not inhale any of these toxic materials and molecules. Your sustainable educations, and that will add to your strength. So friends, I will not go on very long. I thought of not giving you PowerPoint presentations because it is an overview of your theme of the conference because it can't be confined to particular things. So you have to learn from this and take home the mantra and message that have a clean environment in and around your working place and your residence. With this, I once again thank Dr. Gayatri and the organizers and the principals and the Bandodkar management and all of you, the teachers, organizers and participants for giving me this opportunity with you and deliberate on this, something which I've been practicing right from my lecturership and still continue to do it. I was on the street with the issues. There's no time I would have going to many examples of those. I forgot I was a government officer. I went to field, I stopped the Rasta Roko. I confronted with the top officers of the government and the ministers. Inquiry reports, I said, no, I shall not sign unless the to the mankind some contribution to sustainable.
Disconnected, some technical problem.
Yeah, I think we'll move on. Not be able to hear. Yeah, we will move on, madam. I will. Vote of thanks by organizing secretary.
Yes, ma'am.
Please continue.
Please take it.
Yes, ma'am. As we come to the end further, I would request Dr. Captain Moses, sir, Convener in Chief and Chair of Conference, to announce the next year conference, as we are eagerly waiting to again attend such excellent conference. So please.
Yeah. Thank you so much. Thank you so much.
Again,
Yes.
I'm back in.
Welcome, sir. Welcome back. Welcome back. Welcome back.
Winding up only. Thank you for your valuable.
I hope at least till I was talking, it was working, right?
Yes, yes, sir. Yes, sir.
Yeah. And immediately after finish, there was again disconnection.
Yes, sir. Yes, sir.
So it's a very temperamental connection. You know? So no excess, no excess.
Yes, yes.
So job is up, you know.
I thank Sawan sir.
Thank you, sir. Thank you.
I really thank sir for this really, enlightened talk on the hidden dangers all around us,
Sir.
which we see but we don't see, or we don't see, and whatever you call it, but
I spoke both state of mind and state of environment. State of mindset of people, the government, and the environment. You know, these are all they go hand in hand. You know,
they go hand in hand. Sir hit upon some really valid points and unfortunate points which are happening around us. The facts, we can see them happening around us. So it's time now we stop all this and we take inspiration from sir how things were done. I have followed some of sir's projects in the river around his native place.
yes,
around
very true.
So really inspiring work done. So I thank Sawan sir, AD Sawan sir, a real good friend of our college and of the Vidya Prasarak Mandal. I thank all the young scientists, all the scientists from the industry representatives who are here, all the paper presenters, the young researchers, those who have presented their papers in the oral session as well as in the poster session. I thank the honorable judges. I had the honor to hear Mane sir. To thank all the judges. I'm little going out of the way, in encroaching upon the organizing secretary.
Meanwhile, I am happy to know, sorry to interrupt, Dr. Mane, with such a good education, he chose to join my small college in our village, you know, Wada. So I am so happy.
Yes, sir.
The Wada students are very fortunate to have him there, you know.
Really nice.
I am really delighted.
Speaker, Sawan sir, our one of the speaker was from Buldana district, from very small town place.
Oh, great. Yes, yes. That's really roping well. Please go ahead.
Sir, we also promise our support in this venture. If you want teachers on exchange basis from our college, student exchange and teacher exchange, yes, we will go ahead, sir, and do it. We can work on that, sir. So I thank Sawan sir for all this he has done for our college. I thank our Vidya Prasarak Mandal management who has given us this freedom to go ahead with the conferences and also come out with the proceedings. So we'll be coming out with the proceedings with ISBN. It's my duty to congratulate both the departments of chemistry, our own department of chemistry, Bandodkar College of Science, autonomous, under Dr. D.R. Ambodekar sir, as well as the Department of Chemistry of Institute of Science, Homi Bhabha State University, under leadership of Dr. Gayatri. So congratulations on the successful of this national seminar, national conference on advances in chemical sciences and sustainable development, ACSSG 2021. Of course, we have not finished with the conference. The deliberations will go on and the proceedings are yet to come out. But all good things have to come to an end. I was thinking why they have to come to an end. It is because something new can begin. And that something new we are going to announce today. I also thank Dr. Jairam Kobragade, the Director, Institute of Science, for collaborating with us. All our former principals, all the heads of various institutes, teachers, students who are here. And as I said yesterday, students are the backbone of any activity. I should thank our Department of Chemistry here, Dr. Ambodekar, Dr. Anita Goswami, Dr. Ajit Bumkar, Dr. Sandeep Kahandal, Dr. Prahlad Wag, Dr. Rohini Mandre, then Dr. Mohini Kushwa, Dr. Nitin Gulvi, all of them. They make a wonderful team. And if any visiting faculty, of course, if I missed out, I thank all of them. I thank all the students who are here, who have been working as volunteers, and even the master of ceremony of today, the students who have conducted it. So thank you, everybody. It was a wonderful occasion, a wonderful 2-day interaction, deliberations we had, very learning, and the icing on the cake was the enlightening talk by Dr. A.D. Sawan today. I take this opportunity to come to the main point. I have to announce next year's conference. Yes, let us keep our fingers crossed, believing in interdisciplinary work, which is also one of the points with great stress upon today, including our new National Education Policy 2020. We lay stress upon interdisciplinary. So our next conference will be hosted by more than one department. It will be a joint conglomeration of departments of biochemistry, Department of Microbiology, Department of Biotechnology, Department of Botany, and of course Department of Interdisciplinary Studies, and any other department who wants to contribute can join in. It's an open invitation. We have thought of the national conference on microbiome, the story untold. Then there's a colon there. Microbial biochemistry and biotechnology. This will be the next national conference on microbial biochemistry and biotechnology. Microbiome, the story untold. Considering the current situation, the current pandemic situation, the guidelines, the restrictions, etc., etc., two tentative dates we are announcing. One is somewhere around November of this year, 2021, or January in 2022. So this will be our conference. We will shortly enlist the teams. Of course, Dr. Anita, Department of Biochemistry, then Dr. Kalpita, Department of Microbiology, and Dr. Jayashree, Department of Biotech, and Kalpita from Microbiology will have the main role to play in this. So I wish all the best to all of them, and thank you so much. Thank you for being with us. Please carry on. Thank you for this nice learning experience and conference. Thank you, Dr. Anita. Thank you, Ambodekar.
Thank you. Thank you, sir. Thank you very much.
Thank you so much.
Thank you so much, sir, for announcing.
You can have a nice conference photograph by asking all to
Glimpses
switch on
are
their
now
cameras.
time of glimpses of the conference.
Please carry on, please.
Yeah, Pradita.
Thank you so much, Dr. A.D. Sawan, sir. Thank you so much for your word of wisdom and for sharing the thought, making us aware of the harmful things happening in our surrounding and the ground level reality which are faced. Thank you for addressing the conference. Now let us have the glimpses of the conference, and I would request Dr. Vishal Banevar, sir, the Associate Professor of Institute of Science, Dr. Homi Bhabha State University, Mumbai, to proceed with the glimpses. Please, sir.
अनिता मॅडम ऑडिओचं काय प्रॉब्लेम?
सर ऑडिओ नाहीये त्याला याच्यात हे नाही टाकलंय.
Thank you so much, sir. That was so good. Thank you. Now,
Yeah.
I'd like to call.
Hiba, 1 minute. I want to
Yes, sir.
congratulate. I wanted to congratulate you, in fact, Hiba, and who was your partner? I think Aparajita.
Aprajita, yes, sir.
Yes, yes. So congratulations to all the student. Let us say RJs or student master of ceremony. At least congratulations, well done. And any other students also who might be there with you.
Saili Aichal sir, who made the videos.
Video.
Wonderful. And I want to give all the best for the next conference. Biochemistry department, Dr. Anita, then biotechnology, Dr. Jayashree, microbiology, Dr. Kalpita, and I'd forgotten botany. Yes, Dr. Maitri Saha. All the best to you, and of course, please take the small department of interdisciplinary. It is a very small department that also, and anybody else who would like to join in.